perpendicular direction, that is the uniaxial state of stress. The example for uniaxial state of stress is the pure axial loading. Then afterwards you are going to study the pure bending. Pure bending is also comes under uniaxial state of stress. So that will be clear. So whenever a bar is under pure axial loading, on each and every cross section, shear force, bendiment and twistment are 0. On every cross section you are going to get only axial load. At every cross section only you are getting axial load of same magnitude and same direction. Then the shape of the perpendicular direction, that is the uniaxial state of stress. Axial loading diagram. The example for uniaxial
loading diagrams are possible of 4.
Loading.
On every cross section, how many are studied now? 4 loads are possible.
Pure bending also comes under uniaxial.
On every cross section, 4 loads are possible. Axial load, shear force, bendiment and twisting moment.
Whenever a bar is under pure axial loading,
these loading diagrams, that is
on each and
axial
every
loading
section,
diagram, that we are calling a short form of ALD.
force, bendiment and twistment are 0.
Shear force diagram,
On
that is
every cross
SFD.
section you are going to get only
Next,
axial
bendiment
load.
diagram, BMD.
At every cross section
Next,
only you are getting axial load of
TMD.
same magnitude.
Twistment diagram or torque diagram. 4 diagrams are possible. These are called as the loading diagrams.
Then the shape of
These
the
loading
perpendicular
diagrams are
direction,
representing
that is the uniaxial
how
state of stress. Axial loading diagram.
Loads are varying from loading direction to cross section. How magnitude and direction are varying. 4 loads are possible.
Pure
Cross
bending
section,
also comes
that is
under
which load na
uniaxial
axial load, shear
section.
force, bend loads are possible. ALD. Shear force loading diagram represents how axial load, magnitude and direction are varying from cross section to cross section. Loading diagram, that we are calling a short form of pure axial loading. Pure axial loading, shear force every cross section, SFD. At every cross section, shear force bendiment BM0. And axial load, magnitude and direction MD are constant. Then the shape of the ALD will be a rectangle. Possible. These are called as the loading rectangle. Rectangle, everywhere the height loading diagrams are represented as a rectangle.
Axial loading diagram.
Remaining diagrams are the line load distribution. How every the height of the diagram are varying. The shear force, bendiment and twistment are 0. Axial load, shear force, bendiment, pure axial loading ALD. We are going to a real lagging diagram representation. That is how axial load only shown direction varying from cross section to direction diagram. That we are calling a short form of axial loading. And pure axial loading of every direction SF1. Remaining 3 stress are 0. Shear stress 0, bending stress 0. Under pure axial loading, on every cross section you are getting only axial stress. Means shear stress, bending stress, torsional shear stress 0. So whenever you ask the cross section, pure axial loading means on the cross section you are getting only axial stress. Axial stress is a normal stress because of axial load is normal load. But if you ask a member, when a bar is under a pure axial loading, what the shear stress in a member is non-zero. In a member, what now? Stress is defined at a point. At a point, only cross section will not be there. So many planes are there. Infinite planes are there. Under pure axial loading, every cross section you are getting only axial stress. But shear stress in the bar is non-zero. Means that axial load is a normal load for the cross section. What the axial load definition is studied now? Axial load is the load perpendicular to cross section and passes through the centroid. Perpendicular to cross section and passes through the centroid or along the longitudinal axis of the member. Therefore, on the cross section you are getting only normal stress. The remaining shear stress is 0. But if you ask in a member, we have to consider all the planes. Stress is defined at a point. Stress is not defined on a cross section. Stress is defined at a point. At a point there are infinite planes are there.
infinite planes are there. On all the planes, shear stress is not 0. So when a bar is going to be under pure axial loading, the maximum shear stress in the bar is half of the maximum axial stress. Axial stress is P by A. So maximum shear stress is half of P by A. But where you are getting that maximum shear stress? At an angle of 45 and 135 degrees. At an angle of 45 and 135 degrees. But tensile stress is maximum on the cross section. So we are measuring the theta from the cross section. For the cross section, theta is 0. So when the theta is 0, normal stress is going to be maximum. That the tensile stress is maximum. And shear stress is going to be maximum at an angle of 45 and 135 degrees. 45 and 135 degrees. So when a bar is going to be pulled, the tensile stress is maximum on the cross section. Tensile stress is maximum on the cross section. But shear stress is maximum at an angle of 45 and 135 degrees. Is maximum at an angle of 45 and 135 degrees. Based upon this, what the conclusion is studied now. When a mild steel bar is going to be pulled. Mild steel is a ductile material. Ductile metals are weak in shear. Since the shear stress maximum at 45 and 135, the shape of the fracture will be cup and cone fracture. Similarly, when a cast iron bar is pulled, cast iron is a brittle material. Brittle metals are weak in tension. When a bar is going to be pulled, we are getting a tensile stress maximum on the cross section. Hence, fracture will be along the cross section. What is the other name for the cross section? Transverse plane. Cross section is a plane perpendicular along its axis. Cross section is a plane perpendicular to along its axis. Hence, it is known as about now transverse plane. So when a cast iron bar is going to be pulled, the fracture will be along the cross section. But cast iron is a brittle material. There is no permanent deformation. Sudden fracture will be there now. So that is called a brittle fracture. Because the brittle fracture, you are going to get a granular. Granular means rough surface, you are going to get it now. So the shape of the fracture under cast iron bar under pure axial loading is a granular transfer fracture. These are all you have studied yesterday. So whenever you ask in a member, you have to consider every plane. So I'm going to write down the yesterday's answer. Let me conclude it. Now same thing what a pure bending. Pure bending is what now? Pure axial load means what you have studied now. When you are getting a pure axial loading, when two equal and opposite axial loads are applied at the extreme end. So under pure axial loading, on every cross section you are getting a axial load of equal magnitude and like in nature. Like in nature means everywhere is going to be a tensile load. So remaining three loads are 0. Then you are getting a ALD, the rectangle, SFD, BMD, TMD are the line cones of 0. Similarly, pure bending. Pure bending means when two bending couples. We are going to discuss what the bending couple. Those you are already thorough, well and good, but those you are not thorough, sir, what is the bending couple you are going to discuss? So when two equal and opposite bending couples applied at the extreme end, two equal and opposite bending couple applied at the extreme end, it is a pure bending. Means on every cross section you are getting only bending moment. But the bending couple will become as a bending moment only at the extreme end. When a bending couple is applied at the extreme end, that bending couple is called as a bending moment. So at every cross section you are getting bending moment of equal magnitude like in nature. Then the shape of the BMD. Shape of the BMD is a rectangle. Then remaining three loads are 0. Axial load 0, shear force 0, twistment is 0. Then ALD, SFD, TMD are the line coincides 0. So under pure bending also you are going to get a uniaxial state of stress. So this pure bending is studied in the chapter number 5. Then bending equation is what? M by I is equal to sigma B by Y equal to E by R. Bending equation derived as them under pure bending. So when two equal and opposite bending couples applied at the two extreme ends, it is a pure bending. Means at every cross section, the bending magnitude and direction is same. Hence the BMD will be a rectangle. So remaining three loads are 0. That is the axial load, shear force, twistment is 0. Hence on the cross section you are getting only bending stress. Bending stress also going to be a normal stress. So even under pure bending also on the cross section you are getting only normal stress. The shear stress is 0. Axial stress 0. Direct shear stress 0. Torsional shear 0. Only bending stress will be there. Same thing, pure torsion. That is the chapter number 6. Pure torsion is the chapter number 6. That is when two twisting couple. The one twisting couple. If you assume this is what now? Anti-clockwise direction. This is clockwise direction. When two twisting couples are applied at the extreme end. When two twisting couples are applied at the two equal and opposite twisting couple. Two equal and opposite twisting couple means one is the clockwise, one is the anti-clockwise. Applied at the extreme ends. Then the pure torsion. Two equal and opposite twisting couple. Twisting couple is parallel to cross section. Bending couple is perpendicular to cross section. So bending couple is a normal load. Twisting couple is a shear load. This is what a twisting couple. This couple is parallel to cross section. Now this is a cross section. Cross section can be seen from the front. So my finger can also be seen from the front. It is the parallel to cross section. Twisting couple is a shear load. So when two equal and opposite twisting couples applied at the extreme ends of the member, it is a pure torsion. Means the torque diagram is a rectangle. Means at every cross section you are going to get a equal and same magnitude of twisting moment. Equal and same magnitude of twisting moment. Then torque diagram is a rectangle. Then automatically remaining three loads are 0. What are the three loads on the cross section now? This ALD, SFD, BMD, TMD are representing what now? How the loads are varying on a cross section. Not all the planes. Axial load, shear force, bendment and twistment are on the cross sections. So TMD will be a rectangle. Means remaining three loads, axial load, shear force, bendment are going to be 0. Means ALD, SFD, BMD are a line coincides 0. Then the torsion equation is valid, chapter number 6. T by J equal to tau max by R equal to G theta by L. T by J equal to tau max by R equal to G theta by L. It is derived assuming pure torsion. So under pure torsion you are going to get on the cross section only twistment. Twistment is the shear load. Then you are getting only shear stress on the cross section. Then automatically what? Axial stress 0, bending stress 0, direct shear stress 0. So once you are clear pure axial loading is cleared. Pure bending, pure torsion also same. But pure axial loading and pure bending is a uniaxial state of stress. Means stress are developed only in one perpendicular direction. So under pure axial loading and pure bending, you are getting only normal stress. Pure axial loading means you are getting on the cross section only axial stress. Remaining three stress are 0. Bending stress, direct shear stress, torsional shear 0. Similarly, pure bending on the cross section you are getting only bending stress. Remaining three stress are 0. That is the axial stress, direct shear stress and torsional shear stress 0. Similarly, under pure torsion on the cross section you are getting only torsional shear stress. That is the shear stress due to twisting is called the torsional shear stress. The remaining three stress are 0. Axial stress, bending stress and direct shear stress 0. sigma A equal to P by A, change in length equal to PL by A is valid under pure axial loading. Bending equation M by I is equal to sigma By equal to E by R, valid under pure bending. Torsion equation T by J is equal to tau max by R, which is equal to G theta by L, valid under pure torsion. Pure torsion. But pure axial loading and pure bending is a uniaxial state of stress. Pure axial loading and pure bending is a uniaxial state of stress. Means stress are developed only in one perpendicular direction. Other two perpendicular direction is zero. Yesterday I studied what a rectangular X face, Y face and Z face. We have taken this as Z face. Z face is a Y face. And this is what the X face here taken now. So at a point, how many mutual perpendicular planes are there? At a point, there are three mutual perpendicular planes. Three mutual perpendicular plane. So uniaxial state of stress means stress are developed only on one perpendicular plane. Remaining two perpendicular planes is zero. Yesterday, when we are studying the pure axial loading, we have taken the cross section of the X face. Polar axis here taken as the x-axis. So axial stress develop only on the X face. Y and Z face stress is zero. But oblique plane stress are going to be there. So this only most of the students misunderstand now. Uniaxial state of stress means they are going to tell stress develop only one direction. Stress is not developed in all the directions are developed now. But uniaxial means stress are developed only in one perpendicular direction. That is only on one perpendicular plane. X face is developed. If I consider cross section of the X face, then automatically Y and Z face the stress are zero. Similarly, pure bending is also uniaxial state of stress. Then stress are developed only on X face. Default I am assuming the cross section of the X face means we are considering the polar axis of the X axis. But pure torsion case, it is a biaxial state of stress. Pure torsion is a biaxial state of stress means stress are developed in two perpendicular plane. So pure torsion is a biaxial state of stress. What is the reason we are going to discuss now? So whenever you are studying the similar, whenever you are studying a topic, you should know also similar now. Pure axial loading you have studied, then you should also know the pure bending and pure torsion. So I am going to write down the answer for yesterday's workbook questions. Chapter number 1. Question number 30 is Delhi. And chapter number 2. I hope everybody got the same answers now. So these are the answer for yesterday's questions now. Good. So directly you can see the question number 30. Answers are matched good. My dear friend, you need not remind me what I had to discuss. I know. Please try to have some patience. Yesterday I had to start with the pressure and stress. But for that one, this concept is important. That's why I discussed this concept. Otherwise, only you have to remember the difference. So I am going in a particular sequence. I will not skip any of the things. It is my responsibility to complete whatever I am doing. I am going to do it 100% perfect. I am not the person to be focused on hours now. For last 25 years, I am sacrificing so many my personal hours for the benefit of the students. Every year, 700 hours I am going to waste my personal time. 700 hours. That is equal to load of one teacher now. 700 hours means you can count it now. Even if I take the board now, 10 hours into 700 hours means 70 days, means almost 2.5 months of overall work now. I am going to waste my personal time for the benefit of my students now. This I am doing for the, once I joined with the MEDIC 2007 till 2022. Recently I completed 2 batches now. Because this subject weightage is more to save your time. I may be wasting my time now, but my students should get benefited. My students should get benefited. My students who is attending my lectures, for them my class notes should be sufficient. They need not waste their time for referring the another textbook. If I am going to save my time now, if I am going to complete my syllabus without covering the effect, you cannot identify also which topic is missed, which topic is not covered. You cannot identify also. In that case, I will complete the syllabus, but I will not go, so many things will be skipped now. Then in that case, when you are practicing, you are going to be very happy. Syllabus is completed within a short time, workbook questions is completed. But when you are solving the problems, you are unable to complete each and every question. So my intention is, the students who are attending my lecture, my personal time may be wasted. My student time should be saved now, because they are going to be there with so much of belief on MEDIC and me now. They are attending my lectures now. So I should get a benefit. Satisfaction is important. Otherwise, the class notes is not sufficient. You have to refer all the textbooks. Time is a constraint now. When you are solving the question, at that time you are going to realize, so this you are unable to do it, then you have to refer the what now? Textbooks. So once I am mentioning, with my class notes, your concept should be clear and you should be able to answer all the previous year questions as well as the whatever you are up in 2023 or whatever it is now. Most of you are all appearing for the 2023 exam now. Our CMD sir is going to mention now, if you can cut down your subject time hours now. If you can cut down if you are wasting for each batch, 35 hours you are taking more now. Before the COVID I am telling now, when offline batches are there now. If you can save that 35 hours, you can complete the mission design for all the batches now. Mission design allotted hours are 35 hours now. Sir, you can cut down the time, then you can complete the mission design for all other batches. But are not accepted. For me, my satisfaction important. My satisfaction will come only my students are going to be satisfied now. Definitely money is required, but money is not everything. First satisfaction is important. If I can save the time, I can vote now. Each batch 35 hours means almost 700 hours I can save it now. So that hours are equal to one of the teacher load will be there now. So that many hours I am going to waste it for last not 1 year now. Recently this batch is also what offline batch. I taken 145 hours now. Online batch, evening prime batch, it has gone up to 160 hours now. But when they made it 2 days back now, on first day, made it conducted a the Zoom session for the doubts now. On that day, hardly only one student, remaining all the friend, nobody's doubts are, sir, all our doubts are cleared. We are able to, based upon the class notes, we are able to do each and every question now. Only one of the student, maybe one or two. One student is preparing for civil service. Sir, with the class notes, all the concepts are clear, but only I am preparing for civil services. I am not preparing for GATE ESC, but only with respect to the civil service, I have taken optional, it's going to be subject mechanical I have taken. So when I am going for the strength of material, I need your how to prepare it, sir, which questions I have to take it conventional point of view. That was the session. Other friend is probably she has referred the so many test series of low standard. Nowadays so many test series are available in the market now. She has attended that so many tests last year. She was sent the question, but out of that 10 questions she sent it to me on the day. Only one student is discussed with me for almost, the session was conducted 2 hour session was there 3:30 to 5:30. Only one student, 1.5 hour, only one student. Remaining students are hardly, most of their 80% sir, we don't have any doubts based upon the class. We are completed all the workbook questions as well as the previous year question. We don't have any time. In between 1 week we have done it. Only one student. Remaining students are hardly 1 or 2 doubts were there now. Only one student, she took almost 1.5 hour time on Zoom session. Only myself and that student as well as the media team were there, was conducted up to 3:30 to 5:15. But they are not workbook question, previous year questions. She was referring the low standard test series now. There are so many mistakes are there now. They are going to give some data now, but that is not sufficient now. She shared me 10 questions now. Out of that 7 questions are incorrect now. 3 questions they are dead. I have clarified them now. So this is only one institute. It's going to be what now? Spend so much of time for the benefit of the students as well as what now? To clarify because prime batch student, they don't have the direct interaction. Nowadays they are conducted subject wise. 1 or 2 Zoom sessions are going to be conducted. Now, similarly for your batch, you might have already appeared for the Zoom sessions. And once the subject is completed, strength of material, once again we'll have one Zoom session will be there now. So this is only what our CMD sir is going to be the what now? Is top priority for the students now. He will always what now? Try to help the students so many ways now. What are the different ways we can try to help the students now? Is the top priority for the students will be there now. Okay, I hope this there is no doubts. In the question number 30, chapter number 1, the statements was given incorrect now. Reverse they is given now. In a tension test on a cast iron specimen, the failure of the specimen along a plane 45 degrees the cross section. In case of tension test, cast iron, what you have said, a fracture will be along the cross section, but it's given 45 degrees the cross section. That statement is valid with respect to mild steel. So first statement is incorrect now. Second statement is in a tension test on a mild steel specimen, the failure of the specimen is on a cross section perpendicular axis of the specimen. Failure of the specimen perpendicular to axis. Axis means default longitudinal axis. If nothing is mentioned, axis of the specimen means longitudinal axis. Which plane is perpendicular longitudinal axis cross section? Along the cross section, which member will fail? No, cast iron bar will fail. But it's given for cast mild steel is given. So both the statements are incorrect now. Both the statements are incorrect. So these are the two standard questions. Next, chapter number 2, question number 18. The questions are not given, they are scattered. They are not given in a one chapter only, they are scattered. Question number 18. Two statements are given. This type of questions are possible in the previously engineering services. But some students are, sir, shall I do the assertion and reason? Sir, I am preparing for GATE. Always try to do the engineering service assertion and reasons. Because nowadays in the GATE we are having MSQ questions. So this type of questions are useful when you are attempting the MSQ questions. First one is what? A mild steel specimen has a cup and cone fracture. Is correct. What is the reason you have studied now? Mild steel is weak in shear. The failure of the specimen in shear takes place at 45 degrees to the direction of the load. 45 degrees the direction of the load means automatically what now? With respect to cross section is 45 degrees only. Yesterday I studied now. What the angle between the oblique plane and the line of action of the load? What the angle between the line of action of the axial load and oblique plane? 90 minus theta. So when theta is what? A 45 degrees. Mild steel what? A fracture will be at 45 degrees. That you are measuring from the theta is 45. Then what about the 90 minus theta is also 45. So in the question what is given now? 45 degrees to the, when 90 minus theta and theta are equal now. When theta is 45, 90 minus theta is also 45. Suppose theta is 30 degrees, 90 minus theta is 60 will be there now. So in the question what is given now? Sir, you have mentioned 45 degrees for cross section, sir, but in the question is given with a line of, that is also correct. With the oblique plane inclined at 45 degrees, the cross section means automatically the 90 minus theta is also 45 degrees now. So both the statements are correct. So answer will be A. Both A and R are true, and R is the correct explanation of A. Now can you give the yesterday's question? Probably I have not remembered this question I have given randomly. So most of the friends already given the answers now. Check it. I not remember exactly whether this numerical data is correct or incorrect. Okay, check it now. I hope you are given the load is 100 kilonewtons. diameter is given 40. Length is 1 meter. I hope it is given now. And it asks what the first question is asked now. What the first question now? First question will be determine the normal and shear stress on a oblique plane inclined at 60 degrees to the longitude axis given. 60 degrees to the longitude axis. I hope based upon my memory, because this I given at the end of the lecture randomly. I hope the 60 with the longitude axis given means 90 minus theta is given. 90 minus theta is given in the question 60. Theta will be 30 degrees now. Some students are going to make a mistake. So this is the oblique plane. This angle is given in the question now. These two angles are same. $60 is given. Now it asks find out the normal and shear stress on a plane inclined at 60 degrees longitude axis. But in our case, theta is measured from where now? Theta is measured from the cross section. So theta will be 30 degrees. So this is only one mistake they are going to do it now. Some students are going to directly substitute the 60 degrees. They will remember simply equation. Sigma n equal to sigma cos square theta, tau s equal to sigma by 2 sin 2 theta. They will remember that equations only. But they will not remember the terminology. Terminology they are going to be not remembered. In our case, the theta is what now? Inclination of the oblique plane from cross section. But in the question what is given now? Inclination from the longitude axis given. So only this is only one mistake. Some student directly is going to take the 60 degrees. If you have taken this correct now, remaining is simply substitutions only. So in the question it is given 90 minus theta is given. 90 minus theta is from where now? From longitude axis. Theta is what now? From cross section. That's all. Remaining is simple. First, what you have to find out now? What you have studied? Whenever you want to find out the stress on any plane under uniaxial state of stress, whenever you want to find out the stress on any plane, minimum you should know the stress on one plane. That is about now cross section is required. Under uniaxial state of stress, you want to find out the stress on any plane, any oblique plane. Minimum you should know the stress on one plane, that is the cross section. Similarly for biaxial and triaxial, what you have studied now? You want to find out the normal and shear stress on any oblique plane under biaxial. Minimum you should know the stress on two plane, that is x and y or y and z or x and z. For triaxial, we should know the stress on three planes, the uniaxial. So first you have to calculate the so remaining is what now? Simple. So stress on an oblique plane at 30 degrees. Definitely when I am seeing what this question is given now, 30% of students directly they are going to take the 60 degrees because their aim is only remember the equation, but they will not remember the terminology. They are not going to remember now. So terminology in that equation important. So normal stress at an angle of So directly can calculate it. I'm getting a positive. Positive means tensile stress. If normal stress, what is the sign convention for the normal stress? Sign convention for the normal stress, the tensile is a positive. Compress is going to be a negative. If I am getting a positive means a tensile. And what the shear stress now? Check it, your friend is getting axial stresses 79.57. Your friend is given, one of the friend, probably Mr. Anurag is given 79.57. I hope it is correct now. And another friend, Mr. Minal, normal stress is 59.67. I'm writing, these are not my answers. Your friends are written, given. I hope definitely they might have done the calculations correctly. And this will be so they got this value as 19.89. I'm getting a positive means it is going to be clockwise. I'm getting a positive means clockwise. Yesterday what now? The direction of the shear stress is what I'm getting clockwise. That I'm going to show it how to show it as what a clockwise now. I'm getting a positive means a clockwise. If I'm getting a negative means it's going to be anti-clockwise. If I'm getting a negative means anti-clockwise will be there now. Next, what the second question is given now. What the maximum next question is given now? Maximum tensile stress. What the maximum tensile stress? Directly axial stress. And what the maximum compressive stress? 0. What you have studied now? What the maximum normal stress value? Maximum normal stress value got it as P by A. And what the minimum normal stress you got it now? Minimum normal stress you got it as 0. Maximum value got it as P by A. Minimum value I got it as 0. Means remaining all the values are positive. You got the what now? P by A the positive. Minimum value 0. Means remaining all the planes. Remaining all the planes. Remaining all the planes. It is all the values are what? Minimum is 0. Maximum is positive. So remaining all the values lies between 0 and positive. So obviously what now? There is no negative now. So compressive stress is going to be 0. This will be at an angle of 0 degrees. This will be at an angle of 45 and 135 degrees. 45 and 135 degrees. shear stress on oblique plane is 34.45. Okay. So this is incorrect. One of the friend is given incorrect now. Probably you might have taken theta is going to be 30 degrees is taken. Theta is 60 degrees you might have taken. So one of the friend previously is given 19.89. He might have taken theta is what now? 60 degrees. Sine 120 might have taken. That's why I got the incorrect now. So okay, good. So thank you for informing the correction. So who got it? What a 19.89. Probably Mr. Minal or something now. Check it now. You got the incorrect value. You are taken theta is going to be 60 degrees. So I've done the modification already, my dear friend. Satyendra Kumar. Suseskar. Subran Gagan. So I already done the modification. Who is that? 99.89 is given now. Mr. Minal only is given an incorrect answer now. Only one friend has got the incorrect now. Default diameter is in mm. Remember what now? Whenever in the diagram, if the units are not given means is the mm only. Whenever the units are not given mm. Here I written the units meters. So whenever in the diagram, if units are not given in the mm only, try to remember what now? In your engineering drawing and the machine drawing now, always will not try to note all the dimensions are in mm. So remember what now? Whenever the units are not given on a diagram, it is the mm only. If other than mm, they are going to indicate it. Other than, this is what now? It is not mm. That's why I written meters now. So whenever the units are not given means it is the mm only. How it is a Pascal, my dear friend? These units are what? Newton per mm square. I have taken Newton, this is mm. This is Newton per mm square. 1 Newton per mm square is nothing but what? 1 megapascal, not Pascal now. If you are going to put it 40 meters, it is a Pascal. It is a 40 mm. 40 mm. So units are what now? This is in mm. So its units are what now? Newton per mm square. 1 Newton per mm square is nothing but a megapascals only. What this line is representing now? Cross section. Is a 2D figure. This is what now? X face, Y face, and this is Z face. Yesterday studied now. Front view, we can see this now. This is a Y face. Y face will become as a horizontal line. In the front view, is a Y face, this is X face, and this is Z face. Is a cross section. So this can be seen in the side view. This rectangle, this is a cross section. This can be seen in the side view. Front view become as a vertical line. So what this vertical line represent a cross section. and where you can see this Y face. Y face can be seen in the top view, but in the front view become as a horizontal line, and we can see in the front view only Z face. So what this overall square is representing a Z face. Overall square is representing a Z face. X, Y, Z. What this blue color rectangle is representing now? It is about the representation of three mutual perpendicular plane in the front view. Representation of the three mutual perpendicular plane in the front view. Front view is a 2D figure. 2D you can see only now. So we can see only one face can be seen. In the front we can see only Z face. So what is this blue color rectangle? Z face. What is the meaning of this inclined line? Inclined line means perpendicular to the figure now. So this is the Z axis. So what is this overall now? Z face. And what about this red color line? X face. For this one, which axis is perpendicular? X is the X face. This is what the Y face is. A Y face. This face can be seen in the top view, but front face become as about a horizontal line. So what this black color horizontal line is representing now? The black color horizontal line is representing the Y face. Red color line is representing the X face. For this line, which axis is perpendicular? Y. For this black color line, Y axis perpendicular the Y face. This is the X face. And what about this blue color rectangle? Z face. In the front view, you can see only one face. The remaining faces will become as the lines now. This vertical line is the X face. So this is X face or cross section. This is Y face. Y face. So this is your axial stress. Axial stress is always perpendicular cross section. But this will become as what? A sigma x. X means what? In which direction? In the x direction. This is in x direction. Sigma x. This value, how much you got it now? Is a tensile or compressive tensile. And this blue color rectangle is a Z face. Blue color rectangle is Z face. So there is no stress on what now? There is no stress on Y face. There is no stress on Z face. That's why you are called the uniaxial. This is what now? Uniaxial state of stress. Uniaxial state of stress. But for equilibrium, what is required now? For equilibrium, we need the what? Once again, this is going to be about now. Is the X face. For equilibrium, if the sum of the forces should be 0, this is what now? So this is called the uniaxial state of stress. These black color lines are representing the Y face. Black color horizontal and the Y face. Suppose stress is also on Y face and Z face. It is about a triaxial. But your stress are developed only on one perpendicular X direction or only one face, that is X face. Y face and Z face. This is called the uniaxial state of stress. Everybody is going to misunderstand. Uniaxial means they will assume stress are only stress are not one direction. Uniaxial means stress are developed only in one perpendicular direction or one perpendicular face, X face. Suppose the stress is like this. This is what now? Y face. This is sigma y. So then it is a biaxial state of stress. On this face, how much stress is there now? 0. On this face, how much stress is there? At an angle of what now? What the maximum normal stress is got at an angle of 0 degrees. Theta is measured from the X face or cross section. At an angle of 90 degrees, what you got it now? 0. So this figure is representing uniaxial state of stress. For this one example is pure axial loading and pure bending. What is the pure bending you are going to discuss? But stress also develop in y and z direction. It is going to be triaxial. If stress develop x and y, it is a biaxial. So this figure is giving what now? Stress on every plane or only 3 planes? Only 3 planes. X, y and z. These red color lines are X face, black color lines are Y face, and the blue color square is about a Z face. This figure is giving the what now? Uniaxial state of stress will give the what now? Stresses on what the state of stress representing now? State of stress representing the stress on 3 planes. But out of the 3 planes, 3 mutual perpendicular plane, out of the 3 planes stress is developed only on 1 plane, remaining 2 planes 0. So state of stress always represents what now? State of stress always represents the how many stress are developed on 3 mutual perpendicular plane. This figure is representing what now? What are the stresses developed on 3 mutual perpendicular plane? What are the stresses developed on 3 mutual perpendicular plane? This will not give the oblique plane. But if you know the stress on these 3 planes, remaining planes will be calculated by that oblique plane equation. So remember what now? This state of stress will represent the what are the stresses developed on 3 mutual perpendicular plane. But in our case, stress is developed only in one perpendicular plane. So it is called as what now? Uniaxial. Suppose stress develop on 2 perpendicular plane is a biaxial. If the stress is developed in 3 perpendicular, triaxial. If a bar is going to be pulled towards left and right, top and bottom, front and back, then you are going to get the stress in load in 3 direction. X direction is there, Y direction is there, Z direction is there. Then in that case, stress are developed in 3 perpendicular planes now. X face, Y face, Z, that is the triaxial state of stress. So this is a uniaxial state of stress. But from this only what now? Sir, there is no shear stress. Shear stress 0 on this 3 plane. This figure is not giving every plane. This figure is not giving the on every plane. These figures are giving only on stress on 3 planes. So on this 3 plane there is no shear. On X face there is no shear. Y face there is no shear. Z face also there is no shear. Shear means parallel. Suppose this is what a shear. Shear. On this 3 plane there is no shear stress. On this 3 plane shear stress 0 means, but at that point is not 0. But if you take a plane like this now, if you take a plane like this, the oblique plane, for this plane this is a normal stress or shear stress or inclined. Then if you resolve it, you are going to get the 2 components. That only got it what a sigma n and tau s. So remember what these figures are giving stress are only on 3 planes. On the 3 planes shear stress 0. But remaining plane shear stress not 0. For that only we are studying the oblique plane equation, oblique plane. So that oblique plane equations are representing what now? What the advantage of the equations of oblique plane? With that one we can find out the stress on every plane. So just now whatever you have studied, this is a uniaxial state of stress. So if somebody will ask what the state of stress representing, state of stress representing the what are the different stresses develop on the three mutual perpendicular plane. State of stress represent what are the different stress are develop on the three mutual perpendicular planes. When a pure axial loading, what now? Stress are developed only in one perpendicular plane, remaining two perpendicular planes 0. State of stress will not give the stress on oblique plane, they will give only stress on three planes. On the three plane shear stress 0, but oblique plane will not be 0 now. But what the advantage of this now? If I know the stress on this three plane, remaining all the planes, at a point how many planes you have studied? Infinite planes are there. At a point infinite planes are there. At a point there are infinite planes are there. But this figure is giving stress on only three planes, x, y, z. Remaining planes are what? Infinity minus 3. Then how to find out the stress on infinity minus 3 planes? By using the oblique plane equations. This is important now. This is only what now principal stress chapter will be there now. Whatever you have studied is the uniaxial. But when you are going for a principal stress chapter, stress also there in two perpendicular plane, x and y, or y and z, x and z. So whatever you have done it, what now? How to find out the stress on any plane when the stress are developed in one perpendicular direction. But what the principal stress chapter you are going to study it now? How to find out the stress on any oblique plane when the stress are developed on two perpendicular planes. That is the biaxial state of stress. Now what this vertical line is called now? Cross section x face or maximum tensile stress plane, or still what you can call it now is the fracture plane for which material now? Brittle material is a fracture plane for So generally you are going for a cast iron. Which one are the example for brittle material now? Brittle material example are what? A cast iron, concrete, glass. Concrete, cast iron and the glass are going to be brittle materials now. This is what now? 45 degrees plane. That is the maximum shear stress plane. Theta is always measured from here now. On this plane, shear stress is maximum. On this plane, shear stress is maximum. So this plane is called as what now? What this plane is called now? Maximum shear stress plane. Maximum shear stress plane or fracture plane for ductile material. Fracture plane, failure plane or fracture plane for ductile material. Next, your shear stress also maximum at what angle now? 135 degrees. They are at 90 degrees. It is a square 90 degrees. Now for this plane, what the theta value? Sir, 45. It is a 130. Sir, how we are getting 135? Theta should be measured from where now? Theta should be measured from x face in clockwise. This is a clockwise. Always in our case, theta is measured from where now? Is a theta. What is this value now? 135. Because this 90 degrees is a 45, but this is anti-clockwise. But you are measuring in which direction now? Clockwise direction. If I can call A, B, C, D. So for BC plane, what the theta 45. For AC plane theta is 45. For BD plane what the theta 135. Otherwise you can call the 45 degrees anti-clockwise. You can call the 45 degrees anti-clockwise. Now these two planes are called as what? The maximum shear stress planes. These are the what now? Because these are what? The stress is defined at a point. These are all the planes are what? At a point. Stress is what? Defined at a point. Maximum shear stress planes are for then it about mild steel, aluminium. They're all what now? Low carbon steel, medium carbon steel, aluminium. They're all what? Ductile materials. Fracture plane for ductile material, that is mild steel. That's why when a mild steel bar is going to be pulled, one fracture will be 45, another plane will be 135 degrees. On this plane, normal stress not zero. Sigma and star. What is the sigma and star? Now, normal stress on tau max plane. How to find out the normal stress on this plane? What the normal stress equation here written now? Normal stress at an angle of theta equal to sigma cos square theta. Normal stress at an angle of theta equal to sigma cos square theta. With that equation you can find out the normal stress on any plane. What the equation here written now? With the equation you can find out the stress on any plane. Now I want to get the normal stress at an angle of 45 degrees. At 45 degrees what you have studied a shear stress maximum, but normal stress is not zero. At an angle of 45 degrees shear stress is maximum. But normal, how to get a normal stress at an angle of 45 degrees? If I am going to 45 degrees, what you are getting now? What the cos square 45? Cos square 45 is what now? 1 by 2. 1 by root 2 whole square. What the maximum normal stress at an angle of 45 degrees? Sigma by 2. Sigma A by 2. Similarly, at an angle of 135 degrees, at an angle of 135 degrees, what the cos square 135 minus 1 by root 2 whole square. Once again, the sigma A by 2. So this value will be what now? Here also you are going to get it. But what about the shear stress value now? What the shear stress at an angle of 45 you have studied now? If I put it 45 degrees, sin 90 is 1. So I am getting a positive. Positive means a clockwise. So here shear stress is maximum. On this plane, shear stress is maximum. Similarly, at an angle of 135 degrees, what the sin 270? Sin 270 is 1. Sir, minus 1. Then you are going to get it minus sigma A by 2. Minus sigma A by 2 means anti-clockwise. That on this plane it will be upward will be there now. So on 45 and 135 degrees plane, what happens now? Shear stress is maximum. What that maximum value now? Half of the maximum normal stress or maximum tensile stress. But on this plane, normal stress is not, shear stress is what now? Normal stress is not 0. On this plane, the magnitude of normal and shear stress are equal. Shear stress also sigma I by 2. Normal stress also sigma I by 2. But this is not the maximum value. Where you are getting maximum normal stress now? Normal stress I am getting at an angle of 0 degrees. Normal stress getting maximum at an angle of 0 degrees on the cross section. But here it is not 0. Now the doubt they are going to get it. Sir, how do you know it's going to be, how you have taken this as downward? The tensile means away. For this plane the tensile is away. It is also tensile away. Sir, but how you have decided this is downward, how you have decided this is upward? Now first you draw the equilibrium of this triangle. Consider this is what now? This plane. This plane is what now? At what angle to the cross CD? This is a cross section 45 degree. First you draw this triangle. This plane is making an angle of theta from where now? This plane is making an angle of theta from where now? This cross section X face. First you draw this triangle. This is C, D and A. So this plane is at what angle now? So on this plane 45 degrees, what is this value now? 45 degrees is plus sigma A by 2. Plus sigma A by 2 means tensile. And this is what a plus sigma A by 2 means. My assumed direction is what? When you are deriving, yesterday you are taken what now? When you are deriving the equation now, how you got that shear force downward, you got it now, shear force, resisting shear force downward. Yesterday when you are deriving now, shear stress equation is what now? Yesterday when I derived this now, the resisting shear force downward, I am getting a positive value means what now? Yesterday I had taken now, this is sigma n and this is tau s. Sigma n you are taken tensile, I am getting a positive means is a tensile, and this you are taken in the downward direction. See the yesterday derivation now. I am getting a positive value mean my assumed direction are correct. Yesterday when you are deriving, this you are taken tensile you are taken, and this you are taken downward you are taken. I am getting a positive means my assumed direction is correct. This is what now? Sigma by 2. Now here nobody is going to get a doubt. It is a tensile, but how to decide this is a clockwise, anti-clockwise? For this plane, you are going to get a parallel plane. For this one, you are going to get a one parallel plane. Complete the remaining part of the square now. Remaining part of the square. Complete the remaining part of the square now. Where you are going to get the remaining part of the square? Complete the remaining part of the square. For every plane, you are going to get a parallel plane will be there now. Complete the remaining part of the square. So this also what now? C, A, B. Yesterday when you cut it, what you got it now? When you cut it, one left side surface, one right side. Similarly, when I am going to cut it, one cut surface below, one cut surface above. Here you are cut it what at what angle of 45 degrees. So for this plane, you are going to get a parallel plane. This plane is what a parallel plane below, and this is what above. When you cut it like this, you are going to get a two cut surface. One on the right side, one on the left side. But yesterday you cut it what now? Perpendicular longitudinal. But here you are cutting what now? At an angle of 45 degrees now. So this is what this plane is what below. Now both the planes are parallel or not now? Now I can check it now. This is a 45. What about this angle? So it is also 45. What this line once again now? X face only. This is also X face. It is the X face. It is also X face. So this AC line, black color AC line is what now? Black color AC line is inclined at 45 degrees to the right side X face. And what about this dotted one, AC line? It's inclined 45 degrees to the left side x face, left side x face. Now for equilibrium, what you are going to get it now? Equilibrium, sum of the forces should be 0. Means is the upward, means here it should be downward. Now this is a tensile, it is also tensile. Both are tensile only, but tensile means away. This away from the plane, this also away, both are tensile. So always remember what now, always on two parallel planes. Always on two parallel plane. Normal and shear stress are equal, but opposite direction will be there for equilibrium. Always on two parallel plane. Always on two parallel plane. Normal and shear stress are equal, but opposite direction. Here is upward, means the downward. Next, here is what a downward, then here it is going to be upward will be there now. So it is also going to be sigma A by 2. Now you can check it now. This downward and this upward, these two will form a couple in which direction? Clockwise. This is a downward and this upward, they are going to form a couple in what? Clockwise. That's why you call this a clockwise direction. Clockwise. Now this is a tensile, this is a tensile. Now same thing what, sir, how to decide this is anti-clockwise? This is anti-clockwise. Then what do you do it now? This plane, AB plane, sir, BD plane. We are measuring the theta from which face now? Theta you are measuring from the left side x face like this now. First complete this triangle. First complete this triangle. Which triangle now? BCD triangle, you can complete it now. Complete the BCD triangle. Complete BCD triangle. This is B, C, this is 45, but the anti-clockwise. This is not the theta. So this you have to call theta as what? 45 degrees anti-clockwise. But you are measuring theta from where now? Clockwise direction. This is the x face. This is (135). Now, at 135 degrees, what you got it now? If I put it 135 degrees, what the 135? Cos 135 is minus 1 by root 2. Minus 1 by root 2 whole square is the 1 by 2. So once again I am getting plus sigma A by 2. Plus sigma A by 2 means tensile. Tensile. Next 135. But the sine 270, sine 270 is what? A minus. Then you are going to get it minus sigma A by 2. Minus sigma A by 2. Minus means what now? Means we are taken when you are deriving the equation, the stress is like this. I'm getting a positive mean what? This is causing a clockwise, anti-clockwise, clockwise. Yesterday you have taken the, when deriving what? A towers you have taken downward. You got the towers downward. But this is a clockwise I'm getting. Clockwise means it's going to be positive. Now if I'm getting a negative, negative means anti-clockwise. Now I have to put it upward or downward now? Anti-clockwise. I put it in which direction? I put it upward. Somebody said how to decide upward or downward now? Negative means anti-clockwise. Negative means anti-clockwise. So for this one where you are going to get a parallel plane, for this one you are going to get a remaining part of the square, where you are going to get in a remaining part of the square you are getting below. Remaining part of the square you are getting below. So here I am going to put it upward means here is downward. Now these two will form an anti-clockwise. By chance if I put it downward, here upward, now these two will form a clockwise. Now can you draw the remaining part of the square now? Where you are going to get the remaining part of the square? Now check it what, this is 45, is also 45 and this is also 45. In which direction now? Anti-clockwise. But you are measuring the clockwise, what you are going to get it now? So this is a clockwise. Sir, shall I substitute the 135 45? Anyone you can take it. If I take the 135, I have to put it positive. If I am going to take the 45 degrees, is minus. Because you are taken when you are deriving what? The theta was taken in the clockwise. But this is anti-clock, then you have to put it the minus. Now you can check it now. Once again here what now? Always on two parallel plane, what you are going to get for equilibrium here? Downward means is also one, which plane? 135 degrees plane. On 135 degree plane I am getting a tensile. Positive means tensile. Tensile means away. Tensile. Now both are tensile, that only clearly mentioned. Always on two parallel planes, normal and shear stress are equal in magnitude, but their directions are opposite. Will be there, either downward means upward. But this is a tensile, it is also tensile. Next here I taken shear stress upward. Then why you are taken upward? Because I want to get an anti-clockwise and a negative. So here it should be now these two will form a couple in which direction? Anti-clockwise. These two will form a couple in what? A couple is what now? Couple is formed due to two equal parallel opposite force. This stress multiplied by area. Stress multiplied by area, you are going to get a force. This stress multiplied by area of this plane. What the area of this plane? You have taken A dash. This stress multiplied by this area, you are going to get a force. Resisting shear force upward. You are resisting shear force downward. Now these two are forming a couple in anti-clockwise direction. So these two will what now? Couple is always formed due to two equal parallel opposite force. Now these two will form a couple in which direction? Anti-clockwise. These two will form an anti-clockwise. So what is the conclusion? Always on two parallel planes, normal and shear stress are equal, but opposite direction will be there. Normal stress positive or negative. If it is what away from the cross section, it's going to be a tensile is a positive. By chance I am getting negative, this value negative means is what now? Compressive. Compressive means towards. Here towards, here also towards means downward. Here upward, here downward will be there now. And what the sigma and star is representing now? Sigma and star is the normal stress on tau max plane. Sigma and star is the normal stress on tau max plane. So what the overall conclusion now? When a bar is going to be under uniaxial state of stress, under pure axial loading, tensile stress is maximum on X face, that is the cross section. That's why the fracture will be along the cross section in case of brittle material, cast iron. But shear stress is maximum at an angle of 45 and 135. That's why what now you can see now. On 45 degrees plane, what the shear stress now? On 45 degrees plane, what the shear stress now? Plus sigma by 2 clockwise. On 45 degrees plane, for this plane, what the theta 45? For this plane, what the shear stress now? Plus sigma a by 2 means clockwise. On 135 degrees plane, what you are getting anti-clockwise means always on two perpendicular planes. Always on two perpendicular planes. Shear stress are equal or unequal? Equal, unlike. On 45 degrees plane, I am getting plus sigma a by 2. On 135 degrees plane, I am getting minus sigma a by 2. Means always on two mutual perpendicular planes. Shear stress are equal, unlike. Shear stress are equal, unlike. Equal, unlike means what is the clockwise, one is the anti-clockwise. This is very important now. So whenever a shear stress is there, what now? A complementary shear stress. Complementary means what? A perpendicular plane. Always on two mutual perpendicular plane. Shear stress values are equal, unlike. Equal, unlike. But what about the normal stress values now? On this plane, what the normal stress is? Sigma I by 2. Here, what the normal stress value? Sigma I by 2. Here, equal, unlike. On 45 degrees plane, I am getting sigma a by 2. On 135 degrees plane also I am getting sigma I by 2. Means here they are equal and like. Equal and like. But what about these two now? These two also at 90 degrees now. These two also at 90 degrees. But on this two plane, normal stress equal or unequal? Here normal stress is what? A sigma a. But here normal stress 0. Means always on two mutual perpendicular plane. Shear stress are equal, unlike. Always on two mutual perpendicular planes. Shear stress are equal, unlike. But normal stresses may be equal, may be unequal, may be like, may be unlike. You can check it now. X and Y phase are mutually perpendicular. This is a plus sigma a. Here 0 means they are unequal. But once again, these two are perpendicular plane. This is at 45, this is at 135. What the angle? 90 degrees now. On these two plane, normal stresses are equal and like. So always on two mutual perpendicular planes. Always on two mutual perpendicular planes. Normal stresses may be equal, may be unequal, may be like, may be unlike. But always on two mutual perpendicular planes. Shear stress are going to be equal, unlike. Always on two mutual what the other name for mutual perpendicular plane? Complementary planes. Complementary planes are the what now? Mutual perpendicular planes. Always on two mutual perpendicular planes. Shear stress are going to be equal, unlike. Then shear stress on two mutual perpendicular planes are called as what? Complementary shear stress. Complementary. Complementary plane means what? A mutual perpendicular plane. Then stress on mutual perpendicular planes. Stress on mutual perpendicular planes are complementary stresses. So shear stress on two mutual perpendicular planes is called a complementary shear stress. So complementary shear stress are always equal, unlike. Equal, unlike. Equal, unlike. But complementary normal stress, that is the normals on two mutual perpendicular planes. Maybe equal, maybe unequal, maybe like, or maybe unlike. Now, one important conclusion you can make it now. On this plane, which stress is maximum now? On 0 degrees plane or x-rays, which stress is maximum now? Normal stress is maximum. On 45 degrees, 0 degrees plane, x face or cross section, normal stress max. But what the shear stress now? 0. Means whenever normal stress become maximum or minimum, whenever normal stress become maximum or minimum, shear stress is 0. On this plane, normal stress 0 is the minimum normal stress. Yesterday what the minimum normal stress, you got it now. What the minimum value of the equation? 0. But where you are getting that now? At 90 degrees. Maximum value is sigma A. Minimum value is 0. Maximum I am getting at an angle of 0 degrees. Minimum I am getting at 90 degrees. So what the other name for this plane now? Minimum normal stress plane. Now you can check it now. This plane is the maximum normal stress plane. That is the tensile stress plane. On maximum tensile stress plane, what the shear stress? 0. Similarly, on minimum normal stress plane, which is 0, no, shear stress 0. So whenever normal stress become maximum or minimum, whenever normal stress become maximum or minimum, always shear stress 0. Whenever normal stress become maximum or minimum, shear stress 0. Those planes are called the principal planes. Those planes are the principal planes. So what the principal plane definition? Principal plane is a plane on which normal stress are either maximum or minimum, but shear stress 0. So what the other name for principal plane? Maximum and minimum normal stress plane, or planes of 0 shear stress. Planes of 0. They are very, very important now. Whenever normal stress become either maximum or minimum, shear stress is 0. Hence, and vice versa. Vice versa means what? When shear stress 0, normal stress always is going to be maximum now. When normal stress become either maximum or minimum, shear stress 0. And vice versa. That is, whenever shear stress 0, normal stress is going to be either maximum or minimum. Those planes are called the principal planes. Those planes are called the principal planes. So principal planes are the planes on which normal stress is going to be either maximum or minimum. Hence they are called the maximum and minimum normal stress plane, or planes of 0 shear stress. Planes of 0 shear stress. So how to identify where the normal stress? Why you need the maximum normal stress plane? Why you need the maximum normal stress plane? Brittle materials are weak in tension. Brittle metals are weak in tension. Tension means a normal stress. So we want to identify where the normal stress is maximum or minimum. Blindly what you have identified? Identify where the shear stress 0. Wherever the shear stress 0, that normal stress is going to be either maximum or minimum will be there. So principal planes, what the other name? Maximum and minimum normal stress plane. Maximum and minimum normal stress plane, or planes of 0 shear stress. So principal plane can be located by how many methods now? Whatever the definition I am giving now, they are not only valid under uniaxial, even biaxial also. That is only principal stress chapter is also valid now. So how many ways the principal plane can be located? On principal plane, normal stress either maximum or minimum. Means you have to differentiate the equation. Whenever you want to get a maximum and the minimum, what I have to do it now? Differentiate and equate to 0. Or when the normal stress maximum, the shear stress is going to be 0. Or you can equate the equation to 0. So principal plane can be obtained by, principal plane locations are obtained by differentiating the normal stress equation with respect to theta and equate to 0. Or equating shear stress equation to 0. Two ways you can get it. Either you can equate the equation to 0, or you can differentiate and equate to 0. Check it, you are going to get the same value. If you equate it to 0, you are going to put two values. One is 0 and 90. Even if you differentiate and equate it to 0, you are going to get the 0 and 90. So principal planes are located by two methods. One is what now? Either equating shear stress equation to 0, or normal stress equation can be differentiated with respect to theta and equate to 0. But now you can see it now. When normal stress become maximum or minimum, shear stress 0. But when shear stress is maximum, normal stress need not be 0. On this plane, shear stress is maximum, normal stress is not 0. Everybody is going to make their own conclusion. Sarah mentioned when normal stress maximum or minimum, shear stress 0. Then automatically what they will assume now? When shear stress maximum, normal stress 0. Reverse is not correct now. When normal stress become maximum or minimum, shear stress 0. But reverse is not correct. What's the reverse now? When shear stress maximum, normal stress 0 is not correct now. When shear stress become maximum, normal stress may be 0 or may not be 0. When shear stress is maximum, normal stress may be 0 or may not be 0. That's why on these two planes they are non-zero. How much you are getting now? Half of the maximum normal stress you are getting now. This value is how much? Half of this value now. So on maximum shear stress plane, normal stress may be 0 or may not be 0. So maximum shear stress plane be located by how many methods now? Only one method. Which method now? On tau max plane, shear stress is maximum, but normal stress not 0. So tau max planes are located by only one method. Which method now? Differentiating the equation with respect to theta and equate to 0. Differentiating the equation with respect to theta and equate to 0. Next, you can see it now. What the angle between these two planes? 90 degrees. This plane is the principal plane. Wherever shear stress 0, they are called the principal plane. What the angle between principal plane? 90 degrees. So principal planes are always at 90 degrees. So what the other name for principal plane? Complementary plane. Complementary means mutual perpendicular plane. Principal planes are always mutual perpendicular planes. Next, what the angle between the tau max plane? CA and AB. Sorry, CA and BD. They are tau max plane. What the angle? 90 degrees. So principal planes are mutually perpendicular. Tau max planes are mutually perpendicular. But what the angle between principal plane and tau max plane? What the angle? This is one principal plane. Is the tau max. What the angle between these now? 45. Is the another principal plane? Is the tau max. What the angle between the 45? Means principal plane and tau max planes are always inclined at 45 degrees. Principal plane and tau max planes are always inclined at 45 degrees. Means if I know the principal plane location, if I know one principal plane location, directly will get another principal plane. Why now? They are at 90 degrees. And if I know one tau max plane, directly know the another tau max plane because they are at 90 degrees. Or next, if I know principal plane, directly I know the tau max plane. If I know the principal plane, and directly I know the tau max plane. Because the angle between principal plane and tau max plane is what now? 45 degrees. So principal planes are always mutually perpendicular. So what the other name for principal plane? Complementary normal stress plane. Complementary normal stress plane. Tau max planes are always mutually perpendicular. But remember what now? Principal plane and tau max planes are always at 45 degrees. Means if I know one principal plane or one tau max plane, remaining all the planes will get it. So these two planes are called as what now? These are in the short form of PP. But some student will write down what I written PAL, but they will write down principle. It is not principle. We are not studying any principle here now. Principal. At a point, how many planes are there now? At a point, infinite planes are there. But what is the specialty of the principal plane? We have studied what on an oblique plane, what now? We are getting normal and shear stress. But on principal plane, you are getting only one stress. Which stress now? Normal stress or shear stress? Remaining planes, you are getting both normal and shear. Remaining plane, you are going to get both normal and shear. But on principal plane, you are going to get only one stress. Which stress now? Normal stress. Or on this plane, always one stress is 0. Always on this plane, one stress 0. Which stress 0? Shear stress 0. But remaining planes, what now? Remaining planes, what now? Both normal and shear stress will be there. Remaining plane, both normal and shear is there. Tomax plane, you are getting a normal stress or shear stress or both. Both are there. But normal stress is maximum. But shear stress is maximum, but normal stress is not maximum. So what is the specialty of the principal plane? At a point, how many planes you have studied yesterday? Infinite plane. Out of the infinite planes, only on principal plane, only on principal plane, only one stress will be there. That is, only on the principal plane, one stress is there. But always shear stress 0. But remaining plane, both normal and shear will be there. Now, on this two plane, but this plane is what now? Where I am getting a normal stress maximum. So this is called as what now? Major principal plane. On this plane, what a normal stress is minimum. How much is now? 0. On this plane, normal stress is minimum 0. So this plane is called as what? A major principal plane, that I am calling a sigma 1 plane. And this plane is called as what now? Minor principal plane, sigma 2 plane. So always on principal plane, shear stress 0. But normal stress may be maximum, may be minimum. Here I am getting on this plane, normal stress is maximum. But on this plane, minimum, how much is now? 0. 0. So this plane is called as what? The BC plane is called as what now? Minor principal plane, sigma 2 plane. And CD plane is called as what now? Major principal plane, sigma 1 plane. So what the other name I can also call it here now? Major principal plane. That you are calling as a sigma 1 plane. This is another principle, but what the other name here now? Minimum normal stress plane or minor principal plane. Minor principal plane. This is called as what now? So directly this will be called as what? A sigma 1 major principal stress. Major principal stress. So what the principal stress? On principal plane, you are going to get a normal stress or shear stress. Normal stress will be there, but always shear stress 0. Always on principal plane, what now? Normal stress is there, but shear stress always 0. So the on now what is the principal stress? Normal stress on planes of 0 shear stress. Principal stress is what now? Normal stress on a planes of 0 shear stress. This is one plane of 0 shear. This is another plane of 0 shear. So whatever the normal stress on these two planes, we are calling as a what now? Principal stresses. So principal stress are always normal stresses. Principal stress are the normal stress on the planes of 0 shear stress. On the planes of 0 shear stress. But on this plane, normal stress become maximum. That is called as what now? Sigma 1. What the sigma 1? A major principal stress. Sigma 1 is a major principal stress. But this is a minor principal stress. But on this one, what the normal stress? No, 0. Always is not 0. But in this case, I am getting sigma to 0. Sir, somebody is going to ask, sir, here also normal stress 0. What I mentioned, normal stress become minimum. But shear stress always is 0. So what is the sigma 2 value? No, 0. Sigma 1 is going to be how much now? P by A. Major principal stress is P by A. Minor principal stress how much now? Sigma 2 0. So how many? It is a uniaxial or biaxial? Uniaxial state of stress. Under uniaxial state of stress, non-zero principal stress is 1. Under uniaxial state of stress, non-zero principal stress is 1. Means only sigma 1 will be non-zero. Remaining 2 are 0. Sigma 2 and sigma 3 0. How many principal planes are there? No, 3 principal planes. At a point, how many planes are there? No? At a point, infinite planes. Out of the infinite planes, always on 3 planes shear stress 0. At a point, what the infinite planes? At a point, infinite planes are there. Out of the infinite planes, always on 3 planes is shear stress 0. Whenever a shear stress 0, that plane is a principal plane. So number of principal planes are 3. Number of principal planes are 3. Then how many principal stress are there now? So the normal stress on the principal planes is called as what now? Normal stress on the plane of 0 shear stress is what now? Principal stress. So how many principal stress are going to be there now? Sigma 1, sigma 2, sigma 3. Just now you studied. Principal stress is a normal stress on the plane of 0 shear stress. How many planes of 0 shear stress are there? No, 3. So 3 principal plane. So the normal stress on these 3 planes is called the 3 principal stress. Sigma 1, sigma 2, sigma 3. So principal stress are 3. But how many are 0? How many are non-zero? Uniaxial 1 is non-zero. Uniaxial case 1 is non-zero. Remaining 2 are 0. Sigma 2 and sigma 3 0. If we go for biaxial state of stress, non-zero principal stress are 2. Sigma 1 and sigma 2. Your syllabus is biaxial. That's why you are going to study the sigma 1 and sigma 2. Biaxial case, sigma 3 0. If you go for a triaxial state of stress, there are 3 non-zero principal stress. That is not as per the syllabus. Your syllabus restricted biaxial. So if somebody will ask how many principal stress are there? No, 3. But how many non-zero principal stress? How many non-zero principal stress? Equal to state of stress. Uniaxial state of stress, 1 is non-zero. Means automatically remaining 2 are 0. Biaxial means 2 are non-zero. Sigma 1 and sigma 2 are non-zero. But sigma 3 0. But if you go for triaxial, if you go for a triaxial, 3 non-zero principal stress, sigma 1, sigma 2, sigma 3. Now can you, this is what the front view you have drawn it. Now this is the front view. What this you call now? X, Y, and what about this square now? Z face. This is X, Y, and this is Z face. Now can you draw the 3D figure now? How to show the 3 mutual perpendicular planes? Now these are the 3 mutual perpendicular planes. But just now whatever you have drawn front view you can see this black color face, black color square now. This blue color face will be can be seen in the side view. But seeing the front view, what happens now? Seeing from the front, we can see only this black color one, that is the Z face can be seen. This blue color square will become as the what now? X face will become as the vertical line. And Y face, this is the Y face. Y face will become as the horizontal. That only you have drawn it now. Uniaxial state of stress means what? Stress are developed only in one perpendicular direction. So what this three plane, what this figure representing now? Three mutual perpendicular plane passing through a point. Stress is defined at a point. So what this figure representing now? Three mutual perpendicular plane. But when a bar is going to be pulled, like this, stress are developed only on what now? X phase. Y phase and Z phase 0. So it is a uniaxial state of stress. Now you can tell it now. On these three planes, which one is 0? On all the three planes shear stress 0. On all the three planes shear stress 0. So directly these three planes are the principal planes. Principal plane is about a plane on which shear stress 0. Here shear stress 0. Shear stress 0. Shear stress 0. So wherever shear stress 0, that is the principal plane. But so the shear normal stress on these three planes. Normal stress on these three planes is called as what? The principal stresses. Normal stress on these three planes is called the principal stress. But on this plane, normal stress 0 or non-zero? Non-zero. How much is sigma A? But the normal stress on this plane is 0. But the normal stress on this plane is 0. Means the normal stress on these three planes is the principal stress. So one will be non-zero. This is a non-zero. But on this now. So out of the three principal stress, how many are non-zero now? 2 are, 1 is non-zero. That is what? This is sigma 1, sigma 2 and sigma 3 0. So wherever shear stress 0, that plane is the principal plane. Wherever shear stress 0, it is the principal plane. Like this, how many planes are at a point? Infinite planes are there. Already on these three planes, shear stress 0. Shear stress 0 on how many planes? No, 3 planes 0. How many principal planes are possible? 3. Out of the infinite planes, only on 3 planes shear stress 0. So already on these 3 planes, shear stress 0. Means remaining infinity minus 3 planes. Remaining infinity minus 3 planes. Shear stress 0 or non-zero? Non-zero. Means remaining planes are not principal planes. Already shear stress 0 on these 3 planes. So directly these 3 are what? A principal plane. Remaining infinity minus 3 planes. Shear stress will be a non-zero. Means they are not the principal plane. And whenever shear stress 0, that is the principal plane. The normal stress on that plane is a principal stress. Normal stress on that plane is principal stress. But on this plane, normal stress 0 or non-zero? Non-zero. It is a one principal stress, sigma A. But on this plane, normal stress 0. One principal stress 0. On this plane, one normal stress 0. So out of the 3 principal stress, only one will be non-zero. That is what now? In case of uniaxial, one will be non-zero, remaining 2 are 0. So directly this will be called as what now? Suppose your normal is like this, no? This is sigma y. But what is the sigma y here? No, 0. Suppose sigma y non-zero, directly that will become as the what? A principal stress. Now this is what? Now sigma z. Sigma z. So that will become as a principal stress. But what is the sigma z value? No, 0. Because bar is pulled in only in one direction. Other 2 direction there is no normal load. Therefore there is no normal stress. So in case of uniaxial, non-zero principal stress is 1. Remaining 2 are 0. So number of principal planes are 3. Number of principal planes are 3. Number of principal stress are also 3. Principal planes are 3. Principal stress are 3. But non-zero principal stress are 1 or 2 or 3. Depend upon the state of stress. Uniaxial case 1 will be non-zero. Biaxial case 2 are non-zero. Triaxial case 3 are non-zero. uniaxial state of stress means only sigma x will be there now. Sigma y and tau xy is non-zero. Suppose sigma y is non-zero, then the biaxial. For the example, pure axial loading. Now I am preparing a tabular form, just now whatever you have studied. Now from this equation you can make one more conclusion. Further conclusion now is a second order equation. Ax square means second order equation. Why you are getting a second order equation now? How we got this equation? Normal stress now. Normal load at an angle of theta upon area at an angle of theta. But the normal load you got it at an angle of theta, P cos theta, and area I got as about now A by cos theta. Load is also function of theta, area also function of theta. Load is a vector, load is a vector, load is a vector, area also vector. So stress a function of two vectors. That's why I call the stress is a second order tensor. Why you are getting a second order equation? Because yesterday got it the equation like this now. What this you got it now? So load is a function of, load is a vector or scalar. Load is a vector, area also vector, area is also vector, plane to plane area is going to be changes. So load is a stress is a function of two vectors, stress is a function of two vectors. That's why I call the stress is a second order tensor, second order tensor. Stress is a second order tensor. So tensor is about now, tensor, a parameter which is a function of two vectors. So stress is a function of two vectors. Load is also one vector, area is a vector. But everybody is going to mention, sir, area is a scalar quantity. Area for a given plane is a constant, but you are studying at a point. At a point, how many planes are there? Infinite plane. Plane to plane area will change. So area is a vector quantity. Area is a scalar quantity for a given plane. That's when mathematics you are going to write down the vector A. Vector A equal to AXI plus AYJ, AZK. IZK are the unit vectors now. AX, AY, AZ. Area is the vector quantity. So stress is a second order tensor. Stress is a second order tensor. It's a function of two vectors. That's why you are getting a second order equation now. Sigma A cos square theta. So always the stress is a second order tensor at a point. But on a plane is what now? On a plane, stress is about now? Only one. On a plane, if you consider one plane, so stress a function of only one parameter, that load. But area is a constant for a plane. But stress is not defined on a plane. Stress is defined at a point. At a point there are infinite plane. Plane to plane, load will change, area will change. P is also function, load is also function of theta, area is also function of theta. So already everybody know load is a vector quantity only, but area is also vector. That's why stress is about a second order tensor. Stress is a second order tensor. Now can you complete this table now? Can you complete this table now? Why are taken only these 3 planes? Why are considered only these 4 planes now? At a point infinite planes are why are considered now? At 0 degrees normal stress is maximum. At 90 degrees normal stress minimum. And shear stress maximum at 45 and 135. That's why I consider these 4 planes now. So what this value now? At an angle of 0 degrees, what you call it normal stress maximum. What the shear stress now? 0. Next, at 45 degrees, how much you got it now? Normal stress not maximum or minimum, some amount. Some amount. And what the shear stress now? Maximum. What is the meaning of capital T? Capital T means tensile. I'm getting a positive means a tensile. Here I'm getting what this is a clockwise. Next, at 90 degrees, what the normal stress now? At 135 degrees. Who is asking? Mr. Narang. Sir, with tensile load, wouldn't the stress induced will be compressive in nature? How it is a compressive, my dear friend? Yesterday I have already shown it. No, I have already cut it and shown it. आप कल क्लास अटेंड हुआ नहीं अटेंड हुआ क्या? प्रॉब्लम शायद आपने कल क्लास अटेंड नहीं हुआ इसीलिए आपको डाउट आ रहा है. क्लियर आप मैंने कट करके देखा था आपको. How the wrestling force acting away from the cross section or toward the cross section? Yes, please try to go through the notes. If you are getting a doubt, nobody is getting a doubt. You are getting a doubt means that indicates आपने कल क्लास अटेंड नहीं हुआ, शायद आज अटेंड हुआ आज ही, इसीलिए आपको डाउट आ रहा है. That only I mentioned in the first day. My each and every class interdependent. They are not independent classes. If by chance you should miss my classes only when your health issue is there, even if an health issue is there, otherwise you should not miss the live classes. Don't tell any excuses. Sir, I'm having this function, that function. That is what now? For your top priority is what now? Now for your top priority is what now? GATE 2023, ESC 2023. That is your top priority. That is your main goal. If you are going to succeed in your goal, then lifelong what remaining all are going to be, you can fulfill it now. First, fulfill the primary goal. Your primary goal is to crack success in the GATE 2023 and ESC 2023. For that one, you should give a top priority for the classes. You can see last 2 days back now, probably day before yesterday, I was not feeling. On that day what I am suffering with a cold. But I continued the class now. But I can take a what now? I am not feeling well. I can inform the Medici team. Today declare a holiday for the students now. But I didn't came. Still I came to the class. I continue the class now. Because your time is important. Because of me, your time should not be disturbed now. I can simply tell about now. Send a message to the Medici team now. Technical team. Today my health is not permitting. I will not take a class. Even my family members also, they are not permitted now. But still I came to the class. For me what now? My student's goal is important. My student time will not be wasted now. When I am giving the top priority for your goal now. But you should give the top priority for your what now? Goal now. Remember what? Everybody is busy in this world now. Everybody else, some work will be there now. But successful person, they are going to give the top priority towards their goal. Remaining all are secondary will be there now. Who is not busy? Everybody busy. Cat is also busy, dog is also busy. Only who don't have the work now? Dead body don't have work now. Only dead body don't have work. Every living body will have some work. But successful person is going to be give a what now? Priority to his goal. Don't tell any excuses. Even health issues there, you can attend the classes now. You are not coming to the offline outside. You are sitting in your class, attend the class in your room only. Still you can attend it now. But worst case, if any of the what now? Unavoidable condition is there now. You should attend that function now. Unavoidable. In that case, if you want to attend tomorrow's lecture, till now, whatever the 4th lecture, You have to go through all the lectures. Otherwise, please don't attend the next class lecture now. You cannot understand and you are going to get this type of doubt. So much of clearly I explained yesterday and is asking, sir, compressive stress will be developed now under tensile load is asking now. मिस्टर नारंग, आप कल क्लास अटेंड हुआ नहीं अटेंड हुआ क्या? Opposite load means what? That load is acting away or towards now? Opposite only. Opposite only. Is it opposite means compressive load now? Both are opposite only. This is acting away from this cross section. This is acting away from the cross section. Is it a compressive load or tensile load now? Tensile only. Compress means towards now. Opposite means it's not a compressive. It is towards right side. Is it towards left side? But this is also tensile load. Is acting away now. Please try to refer the notes properly. This is what acting away from the cross section. Tensile load means away. It is also tensile load away. Opposite means not a compressive load. That only clearly yesterday mentioned. Stress will be always in the direction of the resisting force. Resisting force always developed similar to the load but opposite direction. Similar to the load, opposite direction. Is a normal load, tensile load. It is also going to be a what now? Normal load. But it is also tensile. If I am pull it, this is also going to pull it now. Suppose by chance this F is towards like this, what happens now? If the F is like this, the compressive, but this member is not in equilibrium now, then the is going to be displaced, will be there now. Clearly explain. If I am tries to pull one of your friend towards me, other friend also going to be pulled opposite direction. When I am tries to pull you now, you will not push me now. I hope your doubt is cleared, Mr. Narang now. Okay. Now, so I have taken the 4 planes. Now what is the first conclusion now? At 0 degrees normal stress maximum. What the shear stress now? 0. At 90 degrees normal stress minimum. Shear stress 0. That only what you have studied now. Whenever normal stress become either maximum or minimum. Whenever normal stress become maximum or minimum, shear stress 0. Those planes are called about the principal planes. And vice versa. That is, whenever shear stress 0, normal stress is going to be either maximum or minimum. That's why these 2 planes are called about the principal planes. But what the difference in these 2 planes? On this 2 planes, shear stress 0 is a principal plane. But on this plane, normal stress become maximum. On this plane, normal stress becoming minimum. So this plane is called about the major principal plane. Major principal plane. But on this plane, normal stress maximum. But what the nature of the normal stress? Tensile. So what the other name you can call it now? Maximum tensile stress plane. And this is what now? minimum normal stress plane, minor principal plane, sigma 2 plane. Now what the angle between these two planes? 90 degree. That's why principal planes are complementary. That's why what the principal plane definition is studied now. Principal planes are the complementary planes. Complementary planes, that is 90 degrees plane, on which अभी थर्ड प्रिंसिपल प्लेन दिखा है ना जी, अभी आपको क्यूब दिखा है ना, आप थर्ड प्रिंसिपल प्लेन दिखा बोले तो अभी दिखा है ना बोर्ड पे. Please, when the lecture is going on, I am not relaxing. Please don't relax. You are alone and you will go to the washroom, or 5 minutes you will attend a mobile phone. What is going on the entire world? Social media, what is going on? WhatsApp, who will send a message? What is going on the Twitter, Facebook? Lifelong you can do all these activities now. I am not relaxing. In my class there is no fraction of second to relax now. And you go for the washroom and you will come back now. Then we will ask what now, sir, can you show the third principal plane? That's why I already shown and you are asking the same thing now. What should I answer now? After I explain also you are asking what now? Sir, can you show the third principal plane, sir? So what are the principal planes now? Principal planes are the complementary planes on which shear stress is 0, but normal stress is going to be either maximum or minimum. Next, what about this 45 and 135? On 45 and 135 shear stress is maximum. Somebody will ask now, sir, the minimum, sir. Don't see mathematically. Don't see mathematically. Sir, this is a plus 100, this is minus 100, sir. Mathematically plus 100 is more, minus 100 is what now? Minimum, sir. So don't write down tau minimum now. Here plus or minus mean direction. One will be for the clockwise, one is the anti-clockwise will be there now. One will be a 45, just now I already shown it now. Don't see mathematically. Mathematically what? This I can call the tau max plane, this is the tau minimum plane. But we are not seeing the mathematically. We are what the plus or minus are representing the direction. This will be what? To form a couple in clockwise, this will form a couple in anti-clockwise. So on 45 and 135 degrees plane, somebody will ask now, why you are not calling the maximum and why the minimum? Because magnitude both are same. Since magnitude both are same, that's why both are called the tau max plane. But sigma 1 and sigma 2 are not magnitude wise same. Suppose sigma 1 and sigma 2 also magnitude wise same, then you can call the what now? Both are maximum only can call it now. But sigma 1 and sigma 2 are always not going to be what now? Equal. But always the shear stress values are always equal. What you have studied now? Always on two complementary plane. Now you can see now on these two planes complementary. On these two planes shear stress are equal unlike. Shear stress are equal unlike. Now you can see it now. What the angle between these two planes? 90 degrees. Once again these two are complementary. On these two complementary, normal stress equal or unequal? Unequal. Here sigma A here 0. Means on two perpendicular plane what now? Normal stress may be equal, maybe on these two planes unequal. But what about these two planes? Once again complementary plane. On these two complementary plane normal stress are equal. So always on two perpendicular plane complementary plane normal stress are going to be maybe equal, maybe unequal, maybe like, maybe unlike. That only studied now. What the angle between these two planes now? 90 degrees complementary. These two are equal or unequal? Unequal. Unequal. But on this two plane, once again they are 90 degrees, but these two are equal. So on two perpendicular plane, normal stress may be equal, may be unequal, may be like, may be unlike. But always on two perpendicular planes, shear stress are equal, unlike. Always on two perpendicular planes, shear stress are equal, unlike. That's why what now? Complementary shear stress are equal, unlike. But what the significance now? What the significance of this plane is a fracture plane for brittle material. And what about these two planes? A fracture plane for ductile materials. Now you can see now, if I know one plane, can you get all these planes now? Is a principal plane. At what angle? 0. How to get the another principal plane? They are at 90 degrees. If 0 means this is 90. What the angle between the principal plane? 90. What the angle between the top max plane? 90. But what the angle between the principal plane and top max plane? This is one principal plane, is a top max plane. What the angle of 45? This is one principal plane, is a top max plane. Once again, what the angle of 45? So principal planes are always at 90 degrees. Top max planes are always at 90 degrees. But angle between principal plane and top max plane is going to be 45 degrees. That's why just now I shown with a diagram wise I shown it now. Now I shown with the table also I am showing now. What the conclusion? If I know the out of these four planes now, if I know the four out of these four planes, if I know one plane location, you can get the all remaining planes. Suppose when you are going for biaxial state of stress, biaxial state, suppose this is 30 degrees now. If this plane is what now? Major principal plane at 30. Can you give the remaining values now? If the 30, major principal plane at 30, what about the minor principal plane? What the angle between the principal plane 90 degrees? This is 30 means this will be what? 120. And this is 30 means what about this now? What the angle between the 45? If the 30 means this will be 75. And if this is 75, this is what? 165. So out of these four planes, if I know one plane, the remaining planes are going to be known now. So what should I call this plane now? Major, short form I am writing now, major principal or maximum plane of zero shear stress. Or brittle material, you can call it a fracture plane for cast iron. So this will be called as what now? What is the other name for this now? Sigma 1 or now what about this plane now? On this plane also shear stress 0, therefore is also principal plane. But on this plane normal stress is not maximum, therefore this will be a minor principal plane. Minimum normal stress plane. Minimum normal stress plane. Plane of zero. What is the specialty of this plane now? On this plane no stress is there. Means there may be a plane on which no normal stress, no shear stress. Already shear stress 0, but normal stress also becoming 0. There may be a some plane on which both normal and shear stress are 0. But they are going to be peculiar case, you are going to get it now. This will be what? Sigma 2. Sigma 2. This is what? Sigma 1 is what? Major principal stress. Is a minor principal stress. Minor principal stress. When sigma 2 0 means automatically sigma 3 is also going to be 0 now. And this plane is about now. Maximum shear stress plane. Don't call the 0 normal stress plane. When shear stress maximum, normal stress may be 0 or may not be 0. Every time what now? We cannot directly conclude. But whenever normal stress maximum or minimum shear stress 0. Or now this is what the normal stress maximum or minimum or some amount now. On this plane, when shear stress maximum, normal stress is not 0. But what is normal stress value now? What the maximum normal stress? Sigma A. What the minimum normal stress? 0. So what this value now? Average of these two now. Average of these two. So this will be equal to on tau max plane, the normal stress value is going to be equal to average of maximum and the minimum normal stress. That is about the average of sigma 1 and sigma 2. Average of sigma 1 and sigma 2. What the notation I am following? Sigma and star. What the notation? The same notation I am going to use it. What now? Entire subject now. So as per our notation, what the sigma and star now? Normal stress on tau max plane. Normal stress on tau max plane. And what about this shear stress? Maximum shear stress how much is now? Maximum shear stress is half of the sigma 1. Half of the sigma 1. Sigma 1 is about the major principal stress. Now once again this plane is about now. Who is this Vaibhav Chauhan? What you are writing, my dear friend? Plane of Jengir. What is the plane of Jengir, my dear friend? What you want to write down and what you have written, Mr. Vaibhav Chauhan? Plane of Jengir. क्या पागल हो गया क्या आपने? क्या लिख रहे हैं, क्या भेज रहे हैं उसमें? This one relation I'm going to prove it. What the meaning of this? Normals on two perpendicular planes. One plane at an angle of theta, one plane at an angle of 90 plus theta. One plane at an angle of theta, other 90 plus. They are complementary plane. So what the meaning of this? Now, sum of the complementary normal stress always equal to sum of the normals on x and y face. Either normals on x face, either normals on y face. Now you can check it now. In our case, when a bar subject to pure axial load, what the sigma x? No, sigma a. In case of pure axial loading, what the sigma x? No, p by a. What the sigma y? 0. Now you can check it now. What the sum of these two values now? At 0 degrees is 90 degrees. What the sum of these two values? No, sigma a. And once again, what the sum of these two values? No, sigma a. So always on two mutual perpendicular plane. Always on two mutual perpendicular plane. Sum of the normal stresses is equal to sum of the normal stress on x and y face. In case of what a uniaxial case, what the sigma x value? No, sigma a. On x face, what the normal stress? No, sigma a. Y face 0. So what the sigma x plus sigma y? In case of uniaxial case, what the sigma x plus sigma y? Sigma a. Sigma x is sigma a. Sigma y is 0. So you take any two perpendicular plane. These two planes are two perpendicular. Normal stress at an angle of 0. Normal stress at an angle of 90 degrees. What the sum of these two? No, sigma a. Now once again, these two planes are 90 degrees. So what the sum of the normal stress at an angle of 45 degrees? Sigma a by 2. And what the normal stress at an angle of 135? Sigma a by 2. What the sum of these two? No, sigma a by sigma a. Because of sigma x plus sigma y equal to sigma. So this is a very important conclusion now. But similarly, what here written now? What the sum of the shear stress on two perpendicular planes is 0. Sum of the shear stress on two perpendicular planes 0. That is what the shear stress on two perpendicular planes are equal unlike. Shear stress on two perpendicular planes are equal unlike. So what should I call these two stress? No, complementary shear stress. Complementary shear stress are always equal unlike. That's why one you got it sigma a by 2, one is minus sigma a by 2. But what about the complementary normal stress? Their sum is equal to sigma x plus sigma y. Now these two are equal or unequal or like or unlike? These two are equal or unequal or like or unlike? Maybe equal, maybe unequal, maybe like or make unlike. Just now you studied now. What is the sum of these two? But what about these two now? Unequal. These two are going to be equal, unlike in nature. But when these two are going to be equal, unlike, when these two are equal, unlike, only when sigma x plus sigma y 0, only when sigma x plus sigma y 0, these two are going to be equal, unlike. Only So normals on two perpendicular planes are equal unlike only when sigma x plus sigma y 0. This is possible only in case of biaxial case. Uniaxial case is not possible. Uniaxial case is not possible. Uniaxial case always sigma x plus sigma y is going to be sigma x plus sigma y is going to be sigma a. Now you can check it now. So this will be 0 or non-zero. So this will become 0 only when sigma x plus sigma y 0. So the normals on tau max plane will become 0 only when sigma x plus sigma y 0. So whenever sigma x plus sigma y is non-zero, this is non-zero. So this plane will become as what now? On this plane, normals will become 0 only when sigma x plus sigma y 0. But when sigma x plus sigma y non-zero, this is a non-zero. Now write down these conclusions now. Now the definition of the principal planes. చెక్ చేయండి సార్. అది ఇక్కడ అది నేను స్విచ్ ఆఫ్ చేశాను. మరి ఈ స్విచ్ అటు అవుతుందా ఇప్పుడు ఛార్జింగ్? ఇప్పుడు అది ఈ అబ్బాయిని ఓకే. Now please write down the definition of principal planes. Now whatever the definition I am giving, once again when I am going for the chapter number 7, principal stress chapter, that is very important, where I am not going to discuss the things which are discussed. They are not going to be discussed once again now. All related things I am discussing at a time now, instead of discussing separately. So there is no meaning now. Some students forget also. Wherever similarities are there, that all I am discussing at a time now. First write down the principal plane definitions. Before that now, Sorry, small. My dear friend, I switched off the mic because I was discussing with the digital person here, technical person. So at that time when I was discussing with him, I was switched off the mic. That's why you didn't get the voice. Now check it. You are going to get the voice. You are able to get my audio now. I identified. So now I kept the mic is on. I hope you are able to hear my voice now. I hope you are able to hear my voice now. Sorry, by mistake, when I was discussing with my laptop was not charging, so I was discussing with the technical person, so I switched off the mic. But after that conversation, I kept the mic was off only. That's why maybe last 3 to 4 minutes you are unable to hear my voice now. I'm going to repeat it. What this statement now? Sum of the normal stresses on two mutual perpendicular planes always equal to sum of the normal stresses on x and y phase. Sum of the normal stresses on two mutual perpendicular planes, or in place of this one, what you can call it now? Sum of the complementary normal stresses. Already mentioned, two mutual perpendicular planes are called as what? A complementary planes. So normal stresses on two complementary planes are called as what? A complementary normal stresses. So sum of the complementary normal stresses always equal to sum of the normal stresses on x and y phase. So now these two are equal or unequal or like or unlike. Maybe equal, maybe unlike, maybe like, maybe unequal. But these two are equal unlike only when these two are equal unlike only when sigma x plus sigma y 0. That is this now. On two mutual perpendicular plane, normal stresses are maybe equal, maybe unequal, maybe like, maybe unlike. But they are equal unlike only when sigma x plus sigma y 0. But what the sum of the shear stresses now? Sum of the shear stress on two planes, complementary planes, always 0. Here there is no condition. Whether it may be a uniaxial stress or biaxial case or triaxial, whatever may be the state of stress, whatever may be the state of stress, whatever may be the state of stress, always on two mutual perpendicular plane, shear stress are equal unlike. That's why what you are calling now, complementary shear stress are always equal unlike. But complementary normals are equal unlike only when sigma x plus sigma y 0. Now, so the normal stress on tau max plane, normal stress on tau max plane 0 or non-zero, may be 0 or may not be 0. When will it be 0 now? Only when sigma x plus sigma y 0. Only when sigma x plus sigma y 0, the normal stress on this one is 0. Next, principal stress are always complementary. Principal planes are always complementary. What the angle between the principal plane? 90 degrees. So principal stress are always complementary normal stresses. Principal stress are always complementary normal stresses. So sum of the principal stress is always equal to sigma x plus sigma y. It is very important now. Whenever a numerical problem is given, after calculation, whether your values of the principal stress are correct or incorrect, always you cross check it like this now. Always you cross check it. Always in the question which is going to be given now, sigma x and sigma y is given. So after calculation of the principal stresses, whether your values are correct or incorrect, always you cross check it now. Similarly, if you go for triaxial, Triaxial, how many non-zero principal stresses are there? 3. So sigma 1, extension of this one is what now? Similarly, under triaxial state of stress, there are 3 non-zero principal stress. Sigma 1 plus sigma 2 plus sigma 3 is equal to sigma x plus sigma y plus sigma z. Sigma 1 plus sigma 2 plus sigma 3 is equal to sigma x plus sigma y plus sigma z. Okay. Now write down the definitions now. Now write down the definitions. Principal planes. Principal planes. Don't write down PLE, PAL. Principal planes. PRINCIPAL. Principal planes. Principal planes are the complementary planes. Principal planes are the complementary planes. Within bracket, that is mutual perpendicular planes. Principal planes are the complementary planes. Within bracket, that is mutual perpendicular planes. Bracket close. On which shear stress is 0. On which shear stress is 0. On which shear stress is 0. But normal stress is either maximum, but normal stress is either maximum or minimum. Normal stress is either maximum or minimum. Maximum or minimum. Hence, principal planes are also known as, principal planes are also known as planes of zero shear stress. Principal planes are also known as planes of zero shear stress, or planes of maximum and minimum normal stresses. Planes of maximum and minimum normal stresses. Planes of maximum and minimum normal stresses. When principal stress are like in nature, planes of maximum and minimum normal stresses. When principal stress are like in nature, like in nature. R, or planes of maximum tensile and maximum compressive stresses. Planes of maximum tensile and maximum compressive stresses. Planes of maximum tensile and maximum compressive stresses. When principal stress are unlike in nature. Just now whatever you have said in the uniaxial case, you are getting only one non-zero principal stress. But when you are going for biaxial, how many non-zero principal stresses are there? No, 2, sigma 1 and sigma 2. If both are positive, both are negative, sigma 1, sigma 2 both are positive, both are negative, then at that time what the other name now? Maximum and minimum. But one is a positive, one is a negative, then you are going to call it what now? One will be a maximum tensile stress plane, one will be a maximum compressive stress plane. Suppose after my calculation, now both are what now? Positive. So what the sigma 1 now? Maximum value 100. Now both are tensile or compressive? It is also tensile, it is also tensile. Now this will be called as what? A maximum tensile stress and this is a minimum tensile stress. Both are negative. One will be a maximum compressive, one will be a minimum compressive. So when should I use the maximum and the minimum word? Maximum and the minimum words are used when both are going to be like in nature. Therefore, principal planes are also known as maximum and minimum normal stresses when the principal stresses are like in nature. This will be called as what now? But both are negative. One is a minus 100, one is a minus 40. Then what the sigma 1 minus 100, sigma 2 is minus 40. One will be called as a maximum compressive, one will be a minimum compressive. By chance I am getting what now? They are all possible in biaxial case. Uniaxial case you are getting only one principal stress. (100) and minus 40. Now sigma 1 is 100. Now this will be called as what now? Positive means tensile, negative means compressive. Now this will be called as what now? Maximum compressive means remaining all the plane, what the tensile stress value are less than 100. Remaining all the plane compressive stress values what are less than 40. So when should I use the word now? Maximum and minimum word now. Principal planes are called as the maximum and minimum normal stress plane when the principal stress are like in nature. But when they are unlike in nature, one will be called as the maximum tensile stress plane, one will be a maximum compressive stress plane. Next, write down now. Principal stresses are the, next line, principal stresses are the principal stresses are the complementary normal stresses. Principal stress are the complementary normal stresses on planes of zero shear stress. Principal stress are the complementary normal stresses on planes of zero shear stress. So if anybody asks what is the principal stress definition, the principal stress is a normal stress on plane of zero shear stress. Whenever shear stress 0, the normal stress on that plane is called as what a principal stress, and that principal stress is representing what now? One will be a maximum, one will be become as a minimum. Somebody will ask now, what is the significance of the principal plane? Sir, zero shear stress. But if zero shear stress is what happens now? Why you need a principal plane? Why you need a principal plane? If I ask the most often what the principal on which shear stress 0. If shear stress 0, what happens now? Normal stress is going to be either maximum or minimum, you are going to tell it now. But why you need a maximum and the minimum now? Because brittle metals are weak in tension. So whenever you want to get a fracture plane for brittle material, we need principal plane location is required. So somebody will ask now, what is the significance of the principal plane? Sir, on principal plane shear stress 0. If the shear stress 0, what happens now? Normal stress is going to become either maximum or minimum. So once you know the maximum and the minimum normal stress plane, then you can identify the where the fracture will get it in case of brittle material. But where the fracture will get it now? On which plane normal stress is going to be tensile. Out of the two principal plane, wherever the normal stress is going to be a on the two principal plane where you are getting a maximum tensile stress. On two principal plane where the normal stress is going to be maximum tensile stress you are getting. That plane is about a fracture plane for brittle material. And what the other advantage? If I know principal plane, directly know the tau max plane. Because of why you need the tau max plane? Because they are the fracture plane for ductile material. So once you know principal plane, directly tau max planes are at what angle now? 45 degrees. Next. Under uniaxial state of stress. Under uniaxial state of stress. Under uniaxial state of stress. Sigma 1, put it like this now. Under uniaxial state of stress, sigma 1 is non-zero, sigma 2 and sigma 3 is going to be 0. And directly that sigma 1 value is equal to how much? Now, sigma x you can call it now. Directly sigma 1 equal to sigma x. Under biaxial state of stress. Next one. Under biaxial state of stress. And automatically triaxial, all are non-zero. Generally, a syllabus restricted to biaxial. Biaxial case, you are getting only two principal stress. So one will be about a major, one will be a minor principal stress. Sigma 1 is the major principal stress, sigma 2 is the minor principal stress. But if you go for triaxial, always what now? Always sigma 1 greater than sigma 2 greater than sigma 3. Sigma 1 greater than sigma 2 greater than sigma 3. Suppose triaxial case, what happens now? This will be called as what now? Major. And this is what now? Minor, you are going to call it. This is the intermediate. In biaxial case, you are getting only two values. One will be a major, one will be a minor. But if you go for triaxial, this will be a major and this is a minor, you are going to take it now. And this is the intermediate, you are going to call it. But generally, your syllabus biaxial, that's why what you are calling now. Biaxial, only two non-zero principal stress. One will be a major, one will be a minor. Sigma to the minor, sigma 1 is the major. But when you are going for triaxial, three are going to be there. So sigma 1 is the major principal stress, sigma 3 is the minor, and sigma 2 is going to be intermediate principal stress, you are going to call it now. So what the conclusion now? This just now already written now. Sum of the principal stresses always equal to sum of the normal stress on the three mutual perpendicular plane. Sum of the principal stresses is equal to sum of the normal stress on three mutual perpendicular planes. How many mutual perpendicular? Three now, x and y now, z. So instead of this one directly, what I can call it now? Sum of the principal stress are always equal to sum of the normal stress on three mutual perpendicular plane. On uniaxial case, sigma y 0, sigma z 0. Uniaxial case, these two are 0. So directly sigma 1 plus sigma 2, sigma 1 equal to sigma x will be there now. This is in case of triaxial, this is going to be biaxial. And uniaxial case, directly sigma 1 equal to sigma x. Next, write down now. Tau-max planes, write down now. Tau-max planes. Tau-max planes. Or maximum shear stress planes. Tau-max planes or maximum shear stress planes are the complementary planes on which shear stresses on which shear stress is maximum, on which shear stress is maximum. On which shear stress is maximum. But normal stress within bracket sigma and star. Normal stress within bracket sigma and star is equal to sigma x plus sigma y by 2. Sigma normal stress within bracket sigma and star is equal to half of the sigma x plus sigma y. Normal stress within bracket sigma and star is equal to half of the sigma x plus sigma y. Next point. On tau max planes, next point, on tau max plane, normal stress is equal to 0. On tau max plane, normal stress is equal to 0 only when sigma x plus sigma y 0. On tau max planes, normal stress is equal to 0 only when sigma x plus sigma y 0. Then continuation right now. Normal stress on tau max plane is equal to 0 only when sigma x plus sigma y is equal to 0. Then tau max planes are also known as planes of pure shear stress. Planes of pure shear stress. What is the meaning of pure shear stress? Only shear stress will be there. On principal plane, you are getting only normal stress, shear stress 0. But on tau max plane, only shear stress when we will get it now. Only shear stress will get only when sigma x plus sigma y 0. On tau max plane, what you have studied now, shear stress is maximum, but normal stress equal to sigma x plus sigma y by 2. So when that normal stress becomes 0, that is when sigma x plus sigma y 0, the normal stress becomes 0, means on that plane you are getting only shear stress. Then that plane is called the plane of pure shear stress. So tau max planes will become as a what now? Tau max plane will become as the planes of pure shear stress only when sigma x plus sigma y 0. I am going to repeat it now. Normal stress on tau max plane is equal to 0 when sigma x plus sigma y is 0. Then tau max planes are also known as planes of pure shear stress. Planes of pure shear stress. Planes of pure shear stress. Tau max planes are also known as planes of pure shear stress. So don't call always tau max plane the planes of pure shear stress. If somebody will ask now, always on principal plane shear stress 0, but normal stress maximum or minimum. But on tau max plane, shear stress always maximum, but normal stress 0 or non-zero means what now? Sir, it is a normal stress on tau max plane, may be 0 or may not be 0. But it will be 0 only when sigma x plus sigma y 0. So can I call the tau max plane the plane of pure shear stress? That is possible only when sigma x plus sigma y 0. Next. Principal plane and tau max planes. Principal plane and tau max planes are always inclined at 45 degrees to each other. Principal plane and tau max planes are always inclined at 45 degrees to each other. Principal plane and tau max planes are always inclined at 45 degrees to each other. You can show like this now. What you have studied now, principal planes are always mutually perpendicular. They are mutually perpendicular. But the angle between these two now once again 90. Principal planes also at 90 degrees, tau max planes also at 90 degrees. At 90 degrees. Now what the angle between these two planes now? 45. That's why what you mentioned now. If I know one plane, suppose this plane is at 30 degrees. If this is 30 degrees, this plane is what now located 30 degrees now. So this will be at what angle now? 75. Either 30 means this plane will be at 75. Either 30 degrees means this plane will be about 120 degrees. And this is already 75 and this plane will be 165 degrees. Out of these 4 planes, if I know one plane, remaining 3 planes can be easily located now. Next, write down. Planes of, next one write down, planes of pure shear stress. Planes of pure shear stress. On principal plane what now? On principal plane only normal stress is there, but shear stress 0. Shear stress 0. But on tau max plane, shear stress maximum, but normal stress may be 0 or may not be 0. Similarly, at a particular value of theta, normal stress 0, only shear stress will be there. Then that plane is called as what? A plane of pure shear stress. What is the other name for principal plane? Planes of pure normal stress, planes of pure normal stress. Because already shear stress 0. So what is the other name for principal plane? Planes of pure normal stress. But tau max planes cannot be called always a planes of pure shear stress. Because on that plane, normal stress may be 0 or may not be 0. But at a particular value of theta, only shear stress will be there. Means normal stress 0. That planes are called as what? A planes of pure shear stress. That is, I don't know. Planes of pure shear stress. These are the non-complementary planes. But principal plane and tau max planes are always complementary. But these planes are non-complementary. These are the non-complementary planes on which normal stress is 0, but shear stress is shear stress not maximum. Where you are going to get shear stress maximum on tau max plane. These are the non-complementary planes on which normal stress is 0, but shear stress is non-zero. Since normal stress 0, that's why you are calling as what now? plane of pure shear stress. So there is no practical significance of this plane. Generally these planes are not discussed. Most of the textbook discuss only principal plane and Tomax plane. Why you need a principal plane on which normal stress maximum? Why you need that plane now? Because if you know the maximum normal stress plane, we can locate the fracture plane for brittle material. And why you need a Tomax plane? On that one, Tomax shear stress maximum. Then we can locate the fracture plane for ductile material. But on this plane already normal stress 0. But shear stress is non-zero. Shear stress non-zero. So on this plane neither normal stress maximum nor shear stress maximum. So there is no practical significance of this plane. There is no practical significance. So only this is academic purpose only. Right on next now. These planes will exist. These planes will exist. These planes will exist. That is what the planes of pure shear stress. These planes will exist when sigma 1, sigma 2 are unlike in nature. These planes will exist when sigma 1 and sigma 2 are unlike in nature. Sigma 1 and sigma 2 are unlike in nature. Sigma 1 and sigma 2 are unlike in nature. Next point. Planes of pure shear stress. Planes of pure shear stress and Tomax planes. Planes of pure shear stress and Tomax planes. Planes of pure shear stress and Tomax planes coincides. Planes of pure shear stress and Tomax planes coincides when sigma x plus sigma y 0. Planes of pure shear stress and Tomax planes coincides when sigma x plus sigma y is 0. When sigma x plus sigma y 0. Now write down the location of the planes now. How to locate the planes now? Location of how many ways the principal plane can be located? How many ways the principal plane can be located? On principal plane, shear stress 0 but normal stress maximum or minimum. So this plane can be located by two methods. One method is what now? Differentiating the sigma n equation with respect to theta and equate to 0. Other one is equating the towers equation to 0. So what the first method here now? First method, differentiating and what the second method now? equating Tau's equation to 0. Tau's equation to 0. So these planes are significant what with respect to where now? Brittle or ductile material, brittle material. Brittle material what? They are weak in tension. So always the tensile stress maximum in which plane now? Principal plane. So these planes are what? If you know the location of these planes, we can locate the fracture plane for brittle material. Next, what about the Tomax planes now? Location of Tomax planes. Location of Tomax planes. On Tomax plane what now? Shear stress always maximum, but normal stress may or may not be 0. So this will be only one method here now. Which method now? Here only one method. But normal stress may be 0 or may not be 0. But here one will be 0, one will be a maximum. This is a normal stress maximum, shear stress 0. Next, location of on this plane what you have studied now, on which normal stress 0 but shear stress not 0, but is not maximum now. Therefore these planes are located by which method now? Equating sigma and equation to 0. These planes are located by only one method, that is what? Equating sigma and equation to 0. But these two planes will coincide only when now? This plane and this plane. On this plane when the normal stress 0, when sigma x plus sigma y 0. On this plane, that's already mentioned, this plane will become the plane of pure shear stress when now? When sigma x plus sigma y 0. So these two planes will coincide only when sigma x plus sigma y 0. So these two planes differ only when now? These two planes are differs. These two planes are differs when sigma x plus sigma y is non-zero. When sigma x plus sigma y is non-zero. Now, can anybody tell what the first method is required or second one is required now? Do I need the principal plane location required or Tomax plane required or both are required or any one is sufficient? Any one. If I know this plane directly, this plane are at what angle of 45. If I know the principal plane directly, I can locate the Tomax plane. Or if I know the Tomax plane directly, can locate the principal plane. So out of these now, any one is required now. Just now you have studied, if I know the principal plane, directly locate the Tomax plane because angle is going to be 45 degrees now. So out of these two, you are going to use only one method. One you are going to use it now. If I know the principal plane, directly I will get the Tomax plane. Or if I know the Tomax plane, directly I will locate the principal plane. Any one plane is sufficient now. So this is about the complete what now? Introduction to your principal stress chapter now. Timing whatever you have studied about now. Uniaxial state of stress. Uniaxial state of stress. Uniaxial state of stress. But in the principal stress chapter, you are going to discuss biaxial state of stress. That is when the stress are there in two perpendicular direction. In the just now you have studied this case, you have studied now. The uniaxial state of stress. This you have studied now. Next, you are going to study the principal stress chapter. This one you are going to study it now. This is what now? This you are going to study in the principal stress chapter. What about this now? Shear. This is shear. So this you are studying is what a principal stress chapter now. In this case directly no principal plane because there is no shear stress. But here we don't know directly principal plane. Here normal stress there, shear stress there. There is not a principal plane. So in this is called the combined stresses. Sigma x, this is what a shear stress. Shear means parallel. Sigma y, shear stress is there. Neither x face a principal plane nor y face a principal plane. On principal plane, which one should be 0? No, shear stress 0. So on this plane, shear stress not 0. So these two are not the principal plane. But here directly no principal plane. Directly these are the principal plane. So directly this will be the sigma 1. But here which one is the sigma 1? We don't know. Why? Always normal stress maximum where? No? Neither this a maximum nor this a maximum. Where you are going to get a maximum, the minimum normal stress on plane of 0 shear stress. But on this plane shear stress 0 or non-zero? Non-zero. On this plane also shear stress non-zero. So in this case principal plane location unknown. There only these methods are required now. So in this case we don't know principal plane, we don't know tau max plane. So there only these calculations are required. But uniaxial case directly you know. Why? On x and y face shear stress 0. Directly these planes are the principal plane. And directly diagonals are the which plane? No. Once you know principal plane, directly diagonals are the tau max plane. Principal plane and tau max plane at what angle of 45 degrees now? So in this case, the equations are compulsory or optional? Optional. But in this case, compulsory. Why? On this plane, normal stress there are, shear is there are, both are there. Both are there. Both are there. So this is not a principal plane. If it is not a principal plane, means what? This stress is not the maximum normal stress. Everybody is going to tell this is what now? Which is the maximum now? Suppose this is 100, this is 200 means, suppose this by chance this value is 100, this is 200. What is the maximum tensile stress means? Everybody going to 200 now. 200 is not the maximum tensile stress. Where you are going to get a tensile stress maximum? On plane of 0 shear stress. But on this plane shear stress is there. So in this example we don't know principal plane location. Why? We don't know location of 0 shear stress plane is unknown. So once you don't know principal plane, which planes are unknown? Tau max planes are unknown. So in this case we cannot locate the principal plane. Means when the principal planes are unknown, we don't know maximum tensile stress plane, maximum compressive stress plane, and we don't know maximum shear stress plane. So in this case all these are compulsory. This only you are going to study in the principal stress chapter. What this plane now? It is not a principal plane. Simply it is called the x face only. It is simply called the y face only. But what about here now? It is the x face, but shear stress 0. Directly the principal plane. It is also principal plane. In this case, directly no principal plane, directly no principal stress. Once you know principal plane, diagonals are the what? A tau max plane. But in this case, neither principal planes are known, nor tau max planes are known, nor planes of 0 shear stress, planes of pure shear stress are known. So in this case only these calculations are required. So once again you have to take a plane at an angle of theta. On this plane once again one sigma n and one tau s. So you have to, yesterday you have derived the equation for sigma n and tau s, in which case now for this case you have derived it. Similarly you have to derive whatever this black color plane, oblique plane. Black color plane, the oblique plane. Once again on this one normal stress and one shear stress. Now you have to derive the equation for sigma n and tau s. On this plane one normal stress, but yesterday equations are not valid now. Yesterday what you written now? Sigma n equal to sigma cos square theta, tau s equal to sigma by 2 sin 2 theta. That is valid in case of uniaxial. But in this case is not valid. Now you have to derive this equation. The same thing whatever you have done it yesterday, the same thing you have to do it now. So this is only what a principal stress chapter now. That is the chapter number 7. So this is called the combined stress. Combined means what now? Are you getting a normal stress or shear stress or both? On X phase normal stress there, shear stress both are there. Combined stress, how many type of stress are there? No, normal and shear. On X phase normal stress there, shear stress there. Y phase also normal stress there, shear stress is there. This is called the combined stresses. In case of combined stresses cases, principal planes are unknown. Means, why means we don't know plane of zero shear stress. When principal planes are unknown means what now? We don't know maximum tensile stress plane and maximum compressive stress plane. Unknown. When the principal planes are unknown, tau max planes also unknown. There these calculations are compulsory. These calculations are compulsory. So whatever I discussed, these are all compulsory in this case. But in this case optional. In this case optional. Why now? If you want you can use it but not required. Directly what a shear stress 0. These two planes are the principal plane. Once you know principal plane, tau max plane at what angle of 45. So these two diagonals are the tau max plane. So in which case directly you can get the principal plane and tau max plane. Uniaxial case directly you will get the principal plane and tau max plane. So whenever you want to get a principal plane, what is required now? I should know where the shear stress 0. If you know the location of 0 shear stress, that plane will become the principal plane. But when the shear stress is non-zero, when shear stress is non-zero, that plane is not a principal plane. Then on that plane, the normal stress is not a maximum. Suppose this, everybody goes, suppose this is 100 and 200. If this is 100 and 200, what's the maximum tensile stress? Some students are going to tell, sir, 200, sir, is the maximum. It is not the maximum because this figure is giving the only on two planes. These figures are giving stress only on two planes, X and Y. But this is not the maximum. Why now? When this will become the maximum now? When shear stress 0. Normal stress is going to be maximum only on the planes of 0 shear stress. But whenever shear stress is non-zero on a plane, that normal stress is not the maximum nor minimum. Blindly remember now, normal stress on any plane should become the maximum or minimum means on that plane shear stress should become 0. But whenever shear stress is non-zero, the normal stress on that plane neither maximum nor minimum. Now on this now, shear stress there, therefore neither the maximum nor minimum. Neither the maximum or minimum. So in this case, we don't know maximum normal stress, minimum normal stress unknown. So there we have to do all this thing now. Where you have to do this now. So this only you are going to study the principal stress chapter now. Because I have explained, because of one of the friend was getting this doubt now. I have given a generalized case, I have given it now. These are all generalized case now. But just in this case, you can directly tell it now. So this is a very, very important now. Yesterday what a ductile and brittle metal different now. Brittle metals are weak in tension. Ductile metals are weak in shear. So when always the ductile material should be designed based upon the maximum shear stress. But we want to get a maximum shear stress, first of all I should know where that plane is required now. We should know the maximum shear stress plane is required. And brittle metals are weak in tension, means first of all I should know where the tensile stress is becoming maximum. But the tensile stress maximum on which plane? Principal plane only. So whenever a tensile stress maximum, shear stress 0. So this is what are very important for mechanical engineers now. When you are going for machine design and theories of failure. This chapter, the principal stress chapter, is very important for mechanical. And these are basic for the theories of failure chapter now. That's why the 7th and 8th chapter are interrelated. So try to understand the definitions. So still to clear, we need what now? After the break, we are going to discuss. After the break, I'm going to discuss. I will show the clearly what now. That cup and cone fracture. Yesterday I drawn the rough diagrams. I'm going to show the cup and cone fractures, granular transfer fracture. Then you are going to show the difference between the stress and pressure. Then we'll come to the state of stress. Clearly what the state of stress I will mention. A state of stress represents the stress on only 3 planes. Stress or state of stress represents the stress on 3 planes. That you are going to discuss after the break of 20 minutes now. As per my watch, It is 11:50. We are going to meet at 12. You can make it as 12:15 because somebody may ask the doubts also in between. So I'll make it at 12:15. We'll make it now. So thank you one and all. If any specific queries, you can send it now. Otherwise, if you don't have queries, you can log off your system. Log off your system and you can have relax for 15-20 minutes. Those who are unable to wait up to 2:30, 2:40, please try to take some, because you are staying in your room only. Ask your mother to provide some if the lunch is going to be available. Those here, sir, I want to have my lunch at early, sir, till 2:30. I'm unable to wait. Then you finish your lunch right now itself now. Those who are going to wait up to 2:30, 3 o'clock also, I don't mind, sir. I will have my lunch at 3 o'clock, well and good. Otherwise, this 20-25 minutes, try to have either some breakfast. Those you already have, well and good. Otherwise, you can have some snacks or something. You relax now. For 20-25 minutes, we are going to meet at 12:15. Bhavani Singh, please check the definition. And tau max plane definition I have given, you can check it now. Mr. Anurag, it is not a plane of pure shear. Plane of pure shear means normal stress should be, shear stress should exist. What the plane of pure shear here written now? Plane of pure shear is normal stress 0, but shear stress should be non-zero. On this plane what now? Normal stress 0, but shear stress also 0. It is not a plane of pure shear. One of your friend is getting a doubt. Sir, this is a plane of pure shear, sir. Normal stress 0. Plane of pure shear means what the definition I have given now? Normal stress should be 0, but shear stress should be non-zero. But on this plane, normal stress 0, but shear stress is not normal stress 0, but shear stress also 0 now. So since shear stress 0, it is a principal plane. Plane of pure shear means what now? Normal stress should be 0, but shear stress should be non-zero. I hope your doubt is cleared. All of you can check it now. This Y face, is it a principal plane or plane of pure shear now? Principal plane. Whenever shear stress 0, that is a principal plane. But it's not a plane of pure shear. Plane of pure shear means what do you mention now? Normal stress 0, but shear stress should be non-zero. But here shear stress is also 0. So this plane is a principal plane. It is a principal plane. Bhavani Singh, I hope you got doubt is cleared now. Your tau max planes. What you written a tau max plane? Normal stress on tau max plane, how much you written now? Sigma 1 plus sigma 2 by 2 or sigma x plus sigma y by 2. Whenever sigma x plus sigma y 0, the normal stress 0, then that plane is called as what now? Plane of pure shears. I clearly given the definition also, check it now. What's your doubt, Mr. Alok Kumar? You are sending the same query. Sir, the 3 principal plane opposite side wall, opposite will counted as profile plane. Why you are in the profile plane? Principal were counted as principal plane in uniaxial. Sir, the 3rd principal plane opposite side. They should pass through a point, my dear friend. They should pass through a point. They should pass through a point. They should pass through a point. At a point, what? There are only we are talking about this is one plane now. The one plane. is a one plane, this is a one plane, and board is a one plane. Suppose here shear stress 0, this is a one principal plane. All the planes should pass through a point, my dear friend. All the plane pass through a point. So this is a one principal plane, this is a one principal plane, and this is what now? One more principal plane. Z said board is a one more principal plane. So these are the three principal planes. Suppose this is sigma x. These are the what now? What this figure is representing now? These are all the plane passing through a point. So now directly these three planes are the principal plane. All these planes are passing through a point. All these planes are passing through a point. Only three principal planes. This is one principal plane. On this plane shear stress 0. On this plane shear stress 0. On this plane shear stress 0. So directly these three planes are the principal plane. Now directly these three stresses are called the principal stresses. Suppose sigma x is greater than sigma y is greater than sigma z. If sigma x is greater than sigma y is greater than sigma z, then this will be a sigma 1, this is a sigma 2 and sigma 3. All the plane pass through a point. Suppose sigma x is greater than this is sigma 1. If sigma x is greater than so directly these three are the what a principal stress because of there is no shear stress. There is no shear stress. Tau xy direction may be a downward or upward. Tau xy direction is maybe downward or upward depend upon the shear force. I taken the downward depend upon the load. Normal stress always not tensile depend upon the load. Stress may be a tensile or compressive. Shear stress is about a downward or upward depend upon the load itself now. Based upon the load only. Can maximum shear stress plane be the pure shear plane that I already given? Upadhyay, check your notes properly. Just now given a conclusion also written now. Plane of pure shear stress and tau max plane. Check the last conclusion now. Tau max plane and plane of pure shear stress will coincide when sigma x plus sigma y 0. Only when sigma x plus sigma y is 0. In that case, tau max plane and plane of pure shear will coincide. Please, for all your doubts, refer my conclusions. Whatever the summary I have given, all your doubts will be cleared. Swaraj Pandey, thank you, but still I am going to be a learner. I am a student in the strength of material subject. There are so many great authors are there who are perfect in the strength of material. I am not still perfect now. I have to learn so many things still now. Whatever is known to me, with that one, I am tries to clear students' queries now. Okay, thank you. We'll take already 12 o'clock. We'll meet at 12:15. Thank you.